Seksiä tihkuu. Seksiä tihkuu. Sä veit mun tuohi sydämen pensalla kastoisen. Sä likin roihahtaa tervas kantona tuhkats palaa. Kuin satakin pidää. Rälläkää mun rakkauden sulle suihkua.
Noniin, joo, kaikki mukaan.
Se on laakia vaena kun runtataan. Poika sinne pesään kasvamaan. Ja rakkauden maito kermaksi vatkataan. Vatkataan. Sä veit mun tuohi sydämen pensalla kastoisen. Sä likin roihahtaa tervas kantona tukkaks palaa. Kuin satakin pidää. Rälläkää mun rakkauden sulle suihkua. Sä veit mun tuohi sydämen pensalla kastoisen. Sä likin roihahtaa tervas kantona tuhkats palaa.
So, funny story. I actually got here on time today after driving into the city and back. I don't... I think the world might be coming to an end soon. Yeah. I actually budgeted the right amount of time for a change. That's strange. Okay. Hey, Jax, first time here? DJ did girl math? Girl math. Sure. Why not? Yeah, I thought I'd be back here by 1. No, we made it. We made it. That's pretty sweet. You haven't heard of girl math. Yeah, anyway, that's strange. Anyway, how's everybody doing? Everybody's doing well? What day is it? Wednesday? It's Wednesday. There we go. Oh, hey, those bots are back. Fun. Yeah. Yeah, as if. I'd rather fail as a streamer completely, Thomas, than use one of those services. I'd rather go bankrupt. In fact, the second that happens is the second I've been compromised. Run. Yeah, yeah, he did. Elvish, yeah. He did, in fact, confirm that. It's pretty good. Anyway, so, yeah, enough about that. Asteroids. So, NASA announced what was in the Bennu asteroid sample from the OSIRIS-Rex mission. You're getting married on Friday the 13th. Good luck with that, Pop. So, yeah. The OSIRIS-Rex capsule, the sample collection, had about 60 grams of asteroid material. But when the science canister lid was first opened, scientists discovered bonus asteroid material covering the outside of the collector head canister lid and base. There was so much extra material, it slowed down the careful process. I think all told, NASA got like over 100 grams of asteroid material, which is actually super freaking cool. Now, here's the kicker. Here's the kicker. We were talking about the Psyche mission yesterday for Space News, and I said how cool it would be if there was, like, carbon compounds on an asteroid out there. I said hydrocarbons, but carbon compounds are also good. Remember they had an issue getting the thing closed. Yeah, that was probably it. The samples that they got showed a high evidence of high carbon content in water, which are building blocks for life on Earth. Which is, yeah, that's kind of a big deal. That's, it's not hydrocarbons, but it's close. That's, yeah. I mean, carbon compounds are all over the solar system. But, yeah, carbon compounds are all over the solar system, but when they combine with water, I mean, that's kind of how we got started on this planet here. That's pretty neat. I can't believe they found moisture in the freaking carbon. That's kind of a big deal. As well as a buttload of organic compounds. Yeah, that's kind of a big deal, dudes. That's actually really sweet. Also, here, let me show you a live stream of the internet moving through Southern California right now. Check this out. There's a live stream of the internet. See? It's moving down the street in California. This is a live stream. It's a series of tubes. Isn't one of the theories of how life started that an asteroid crashed into Earth? Yeah. And that's why the moon has a very similar compound, Brie. But the moon has been here before, since before life started on this planet, or before life started evolving on this planet. Yeah, okay, I got you. What is this tube for? Well, that is a 4-segment solid rocket booster casing that's going to the California Science Center to be stacked at the Endeavor exhibit. So, if you guys don't know...
Discovery, go and throttle up.
So if you guys don't know, here, I'm just getting a picture of it up. Endeavor is going to be stacked, a real space shuttle is going to be stacked with real SRBs and a real external tank. It's the last complete shuttle stack that's going to be stacked inside of a building at the California Science Center. Real space shuttle, real external tank, real SRBs. Pretty cool, huh? And that right here is a live stream of the boosters being moved down the street to the California Science Center. And it looks like the stream took a dump. There they are. And that is that same building under construction. You could see the aft booster skirts are already stacked. The funny thing is that they're stacking it exactly how you'd stack a shuttle stack. But I'm trying to see if I can get my bearings here. Where are we relative to the rest of the museum? There's the SRBs right there. Okay, there's the parking lot. There's the A12. The A12 is right there. And the California Science Center is over there. Okay, I know where this building is. Sweet. You can see right there, there's the 2 SRB skirts. The shuttle is going to be right here. I mean, personally, I think they should have taken an MLP and put it right there, but that's just me. There you go. There's an A12. See the A12 sitting over there? This is right by USC. And the LA Coliseum is right over there. How would you get an MLP there? With cranes? With cranes? All right, Dink. I understand the logistical complications of that. You're telling me we can't do it? Bull snot detected. You can just cut it up. Cut it up, weld it back together. No big deal. Or at least take the tail service mast umbilicals. That would be the cool part. Take the TSMs. But nah, it's fine. It's okay. This is still cool. Yep. They're building it right down to the California Science Center right here. There's a bunch of cool stuff inside of the Science Center, believe it or not. Apollo capsules, Gemini capsules. There's a bunch of good stuff in there. It's actually a really killer museum. And now it's going to have a full shuttle stack. I'm thinking blimps. Okay. So, see that parking lot? Just on a side note, that parking lot's actually really cool. It's a parking garage, but it's sunk into the ground. So the top story is actually on ground level. But it's also kind of open with trees around it, and there's also an A12 right there, which is really cool. So what shuttle are they using for this? Endeavor. Endeavor's actually in a hangar that's just down the street. Well, not down the street. It's right next to this. Here, let me pull up Google Earth. All right, let's take a look-see. Hey, Chaos. What's going on, buddy? So this is in Los Angeles here. And it's right here. No, down a little more. Here we go. All right, so we're talking right here. There's the A12. Well, you can start to see it under construction. The shuttle is actually over here right now, and the external tank is right next to it. Shuttle's inside, the ET is outside. That's external tank 94. It's an LWT, so a Block 2 tank design. It's not really called Block 2, but that's a good way to think about it. There were 3 different types of external tanks that were made during the shuttle program. There was external tank, like, just regular, prime, right? And there was ETLWT and then ETSWLT. The external tanks by the end of the shuttle program were actually a couple thousand pounds lighter. So about a metric ton lighter because of welding optimizations. Friction stir welding and the application of rocket fuel tanks actually came about because of the shuttle. They started doing this in the late 80s. And external tank 90, or actually late 80s, early 90s. External tank 94 here, which was the 94th external tank made for the shuttle program, was actually an extra because they replaced it with the super lightweight, the SWLT, super lightweight tank design. And so they actually ended up never using it. So that is a real external tank. But it's an external tank from the shuttle program circa the 90s. But hey, whatever. They all look the same pretty much on the outside except for the bipod strut. But so the shuttle is in here, the tank is in here, and they're going to roll the tank back over here once the SRBs are mounted, right? And they're going to pull the shuttle out of the hangar and bring the shuttle down here and stack the dang thing. Hey, Tessa. So that's actually really freaking cool that the SRBs are there because that's this marks, yeah, this is going to be it's the last shuttle stack. The last shuttle stack around. I don't think there's enough to make another complete stack unless there's another ET. There is one more ET lying around. I know of one more that could be used. But, yeah, pretty sweet. If this is in Los Angeles, did the external tank completely burn up on re-entry? Or could it have hit some boats once in a while? No, completely burned up, Jonas. In fact, they put the tank on a trajectory to make sure that it burns up. All of it got... No parts hit the ground. You got to remember, the external tank basically comes back from orbit. It's 98% of the way there. So we're talking about hitting the atmosphere going 27,000 kilometers an hour. It burns up. When it actually separates from the shuttle, there's valves. There's valves inside of the plumbing, and they actually vent the tanks. They vent the hydrogen and oxygen out, and that acts as RCS and flips the tank end over end. And actually flipping it end over end makes sure that it blows up. Because believe it or not, if it just nosedived through the atmosphere, some of it probably would make it. You don't want that. They flip it end over end to make sure and give it a nice good RPM to make sure that it completely burns up. Yeah. And even if it doesn't, where the ETs would come down would be somewhere near Diego Garcia in the Indian Ocean. There's no shipping lanes out there. So it's minimally invasive, even if some parts do make it down. But most of the time, no, probably not. Good question, though. So yeah, external tanks are actually super rare. There was like probably about 140 of them made throughout the shuttle program. If I had to guess, like including test articles and stuff. There is one more ET. There used to be 2, but weather. So if we zoom out from the California Science Center, which is in Los Angeles, right? It's right by the LA Coliseum where the Rams and the Chargers play there. And the NASCAR does NASCAR things there. Yes, the NASCAR. The Coliseum is a gigantic stadium for what it's worth. It's one of the biggest stadiums in the world. Can we watch the OSIRIS-Rex announcement? Or are we going to do that later? Yeah, we can replay it, Bree. There is another external tank. Well, there used to be 2. One of them was over here at Michoud. It was a space shuttle test article, and it's not there anymore. The reason why it's not there anymore is because hurricane. Hurricane came through in 2017, I think, and destroyed it, and a couple of shuttle test articles. And that hurricane actually set back, not a lot of people remember this, that hurricane actually set back set back SLS too, because it damaged Michoud and they had to stop. They were down for 6 months because of the hurricane. There was an external tank test article out there. These are the early shuttle external tanks right here. The ET test articles for the hydrogen tank and the LOX tank. They were sitting out there and a hurricane took them out. They were sitting out there and then they weren't because they got absolutely thrashed on. See, there's pieces of it over. You can actually see pieces of it around. I never bothered to look. There is literally pieces of it everywhere. That's good. Lovely. There is one more external tank that I know of that you could use for a shuttle stack. Something like that, Hellfish. The other tank is sitting in a really weird spot halfway between Orlando and Jacksonville. It's in up here. Green Cove Springs. That is... you know what? I'm not 100% sure what that is. I think it's just an extra that they had, like ET-94. At the end of the shuttle program, they sold it to a museum, and the museum went belly up, and it's literally been sitting here on this dock for the last 10 years. Interestingly enough. The one at KSC is fake. The one at KSC is absolutely fake. That empty shuttle stack that's in front of the Atlantis exhibit is not real. It is... I'm telling you, that shuttle stack is not real. Okay? That's a real external tank, and I'm not 100% sure why it's there. I think it was an extra for the shuttle program. But yeah, it's just sitting out there. There's a whole abandoned airport out here, which is kind of crazy, because there's a bunch of cool stuff sitting out here, like a junk P3 and a junk hovercraft, and... Oh, there was a hangar there. They demolished it. Interesting. Yeah, gigantic freaking tarmac, huge airport just sitting here. It was, this was a military base. I forget which one it was, though. It was a Navy base, and it had a huge, heavy dock here for ships. Anyway. Are the runways X'd out? If a runway has an X on it, it means it's abandoned. It means it's not an active. They don't seem to be X'd out, but I wouldn't... I mean, you could probably land on that in an emergency, I suppose. Yeah, there's a bunch of cool stuff down here. I forget what this military base was used for. It had something to do with the Navy because of the heavy dock. Oh, look, a drag strip. Yeah, maybe. Yeah, maybe. That's where the only other external tank that I know of is. But yeah, still really cool. Anyway, let's see. Let's see if we can see what's good. The OSIRIS-Rex stream. Here, let's play it back. Let's see what we got. The stream is ended. It was still going. They were doing Q&A when I started, but let's take a look and see what's up.
Wow. Don't be afraid to clap or cheer. Today is a celebration. And what you just witnessed was a glimpse of years of hard work and dedication from a devoted and collaborative team.
Here, let's back it up. See if we can see that footage. Apparently the one in Green Cove is an STA. Yeah, that makes sense.
Has come to an end. Marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system.
Psyche News.
Wow. Don't be afraid to clap or cheer. Today is a celebration.
Yay!
And what you just witnessed was a glimpse of years of hard work and dedication from a devoted and collaborative team. They dared to pull off what some would call seemingly impossible, to gather our largest asteroid sample ever and bring it home safely to Earth. I'm Shaniqua Vereen with NASA's Office of Communications, and I will be your host today as we bring you to the heart of the Johnson Space Center's Curation Lab, introduce you to some of the team members hard at work, and provide you with a first look at our initial findings. Thank you all for being here, and welcome to the much anticipated OSIRIS-Rex sample reveal.
Worm.
All right, we'll kick things off, and we'll start with a proper Houston welcome. I'm pleased to introduce to you Vanessa Weich, Director of the Johnson Space Center.
Thank you, Shaniqua. Good morning, and welcome to NASA's Johnson Space Center. We're here today for a very exciting moment in history, the sample reveal of OSIRIS-Rex. The Johnson Space Center has played a pivotal role in many firsts in human spaceflight, from landing the first person on the moon to supporting NASA.
Hey guys, how about you move the teleprompter near the camera instead so, you know, the JSC director doesn't constantly look to her right? No? No, I guess not. Nah, see, the teleprompters are 45 off of the camera, so.
And now,
that's why
NASA's first mission to deliver the largest sample collected from an asteroid to Earth. We are the hub of human space exploration, home to America's astronaut corps, mission operations at the Johnson Space Center. Our workforce also includes the world's leading sample scientists, and we curate the most extensive collection of extraterrestrial materials on Earth.
What up, Plus?
We're honored to be joined by some special guests today. Please help me in welcoming NASA leadership, Administrator Bill Nelson, Director of Goddard Space Flight Center, Mackenzie Lystrup, and Director of the Planetary Science Division in NASA's Science Mission Directorate, Lori Glaze. They'll be out soon. Sharing scientific data with the world, our curation lab will distribute fractions of the asteroid Bennu sample to a sample analysis team of more than 200 members from more than 35 globally distributed institutions. We're pleased to be joined by the international community with representatives from Japan Aerospace Exploration Agency and the Canadian Space Agency, who will both curate a portion of the sample for analysis. As we venture to explore to deep space, our collaborative international partnerships will bolster space exploration and enhance peaceful relationships between our nations.
You know, the whole point of having teleprompters is to make it so somebody doesn't look like they're reading from a script. I'm just saying, they're doing the JSC director pretty dirty right here. Just saying.
Represented today by Houston Independent School District. Where are you guys? And the San Antonio Independent School District. The sample
not even saying she should memorize the whole damn speech.
New
just put the teleprompters not at 45 degrees so you're not doing this all the time. It's like me reading chat.
And a large fraction will be stored and available for future generations of scientists, and that could be one of you. I would like to also recognize we have representation here from the offices of Senator Cruz, Representative Jackson Lee, Representative Brian Babbins, Representative Weber, Representative Garcia, Representative Fletcher, also from the Office of State Senator Middleton and State Representative Bonin. And we thank them for their bipartisan support. Thank you all for being with us to witness history in the making. OSIRIS-Rex embarked on a 7-year journey to Bennu and back to bring us this sample. In fact, the mission was selected in 2011, so this historic day has been in the making for 12 years. Can we get a round of applause in celebration of the researchers at the University of Arizona Lunar and Planetary Laboratory, Lockheed Martin, Jacobs, the NASA workforce, and all those across the agency who came together to make this very exciting moment in history happen. Let's give them a round of applause.
Am I crazy, or is this being broadcast in an interlaced format? See all the artifacting that's going on around her glasses and stuff? Arizona. It looks interlaced to me. It is in 4K. The res is in 4K, but it looks like 4K at 1080i, unless I'm crazy.
And for us all to experience our next
an interlaced
giant leap
picture,
together.
All right.
Thank you.
Like, see the artifacting around the NASA logo? I don't know if you guys can see that on the screen, but I definitely can. It's 2160p. It's 21. Well, it says 2160p right there. That doesn't look like a progressive scan to me, unless I'm totally off my gourd.
Thank you, Director Weich. A mission like OSIRIS-Rex is bigger than one person, one agency, or even one nation. It takes the careful work and collaboration of hundreds of engineers, scientists, mission managers, and more. Our next guest leads the NASA Center that oversaw the mission management systems engineering, safety mission assurance for OSIRIS-Rex. I am pleased to introduce the Director of Goddard Space Flight Center, Dr. Mackenzie Lystrup.
Director Dr. Cowboy, astronaut millionaire.
Hello, everyone, and thank you, Shaniqua, and thank you, Vanessa, for hosting us here today. This is an exciting example of NASA, one NASA center passing the baton to another, and is really NASA at its best and most collaborative. You know, this mission exemplifies that collaboration is what leads us into a new era of exploration. And this is the era of sample science. This is when sample science really begins. OSIRIS-Rex took aim at some of the biggest questions in exploration and science. You know, how did our solar system form, and how did life originate on Earth? It can't get more exciting than that. We can't answer these kinds of science questions without fantastic engineering. And I'm really proud of the team at Goddard, at Lockheed Martin, and at the University of Arizona that oversaw the mission for more than a decade. It's really scientists and engineers coming together in order to make our scientific dreams come true. It was exciting to be in Utah just a few weeks ago and seeing the moment that the capsule hit the desert floor after 7 years in space. It was an exciting moment to see, but really the real journey begins now. It's worth remembering that this team accomplished almost the impossible here, and we were able to, from the maybe back of the envelope science ideas of what OSIRIS-Rex could possibly do, all the way through to conceptualizing this amazing mission, building it, testing it, launching it,
Tessa, that's
going to the asteroid, taking the sample, coming back to Earth,
what the hell?
Landing in Utah, and now here at home at Johnson Space Center. This is the smallest body we've ever orbited before. At one point, it was orbiting only a radius of 0.6 of a mile. I mean, that's just walking distance. So it's really
0.6 of a mile. So 1 kilometer for the metric folks. Yeah.
A brand new era for us
Just
at
thought
NASA.
I'd let you know.
And it's the first time that the United States has brought a sample back from space and landed it safely on Earth. We've been able to map the entire surface of Bennu in detail to find the safest and best landing site, and it's really helped us understand these kinds of asteroids in more detail. But now, of course, we are going to be looking in
Dave, I'm
detail
looking
for
at
the
it like,
first
what the
time
hell?
at these samples.
What is this?
So
this isn't 4K.
we're at the point where we have justified all of the
It's
really
okay,
hard
Chaos,
work.
I got you, man.
And again, we're handing the baton off to the really world-class sample facility here at Johnson Space Center. So I want to give a round of applause to Johnson here.
It's okay, guys. I'm fluent in the metric system and the lunar measuring system too. Yeah, I went there. Oh yeah.
So you hear today that our scientists are incredibly eager to get at the samples. I know that there are Goddard scientists as well who are waiting for their small piece of the sample. So over the next months and years, we're all going to be definitely rewriting some history. When we do, I want all of the team members and their families to really recognize that the revelations that we're going to make here are standing on the shoulders of the incredible engineering and science that you've all delivered. Thank you and enjoy today.
You're not sorry. Yeah, you're right, pajamas. My bad. I'm not sorry.
Thank you, Dr. Lightstrup. Johnson Space Center is best known.
I think, Tessa, I think that this is a upscaled. I think it's the upscaling that's screwing with the interlacing here, or the upscaling that's screwing with the scan here. It's vertically interlaced. It looks like it's 1080p upscaled to 4K. That's my guess.
To integrate terrestrial and planetary research and to promote successful space missions by mitigating risk.
Either that, or the cameras are in 16:9 and they're broadcasting in 16:10 and it's stretching the image. Or vice versa. It's either way. It looks like those children back there are low resolution. That's okay.
Has the world's leading sample scientists and creates the most extensive collection of extraterrestrial materials on Earth, which includes lunar samples from our Apollo missions, cosmic dust, solar wind particles, meteorites, microparticle impacts, the JAXA-led Hayabusa and Hayabusa 2 asteroid samples,
it's nostalgic.
and now OSIRIS-Rex and the samples we collected from asteroid Bennu. Our team has been caring for the OSIRIS-Rex sample and its contents since it arrived in Houston on September 25th. Now let's hear from a crucial member of the team. Please join me in welcoming Dr. Eileen Stansberry, Chief Scientist at NASA's Johnson Space Center.
Kids are low res in real life? They are just smaller humans. What the hell? You're right. Are children just LOD adults? That's weird.
Thank you. I'm honored to be here celebrating with you all today and representing science at JSC. This sample return mission is an important part of an integrated planetary exploration strategy answering fundamental questions on the formation and evolution of our solar system. The pristine sample material from Bennu represents a valuable resource providing a window into the early solar system and is the newest addition to NASA's astromaterials collections. Our role in astromaterials curation is to catalog and safely contain received samples. The process for deintegration and curation for OSIRIS-Rex has been thoroughly planned and practiced with the mission science team. Opening the science canister and methodically removing tag SAM revealed an abundance of sample from asteroid Bennu, and even though the tag SAM head is not yet open. With this abundance, we're taking our time methodically processing to properly care for every valuable piece of Bennu. And with the overflow of sample found on the avionics deck spilling out of the tag SAM, we have plenty to show you today.
Cool.
The science obtained during the mission so far, coupled with the samples we're only now getting a glimpse of, are just the beginning of the wealth of knowledge that we can expect from OSIRIS-Rex. Sample return missions are unique. They provide for large sample science return using advanced instrumentation that you cannot fly on a spacecraft. Analysis is not limited by the ideas formed years ago when the missions were first conceived, and measurements can be made and cross-compared using different techniques to resolve unexpected or ambiguous results. The samples are then available for new questions, new techniques, new instrumentation far into the future, and they are the gift that keeps on giving. I'm proud of the stewardship that we commit to these samples as we begin this next phase of the mission with sample curation and scientific analysis, celebrating the legacy that the OSIRIS-Rex mission is providing to current and future generations of scientists. Let's take a look at the people and labs that are working with our newest astromaterials, the OSIRIS-Rex samples of Bennu.
The OSIRIS-Rex mission was a spacecraft that launched in 2016 to collect asteroid samples from the carbonaceous asteroid Bennu.
And carbonaceous asteroid means it's a likely storage for prebiotic compounds, so organic compounds that could have been the building blocks for life on Earth and potentially other places in our solar system.
And some of these samples may even have remnants from before the solar system, pre-solar grains that allow us to study the raw material that made ours and other planets.
With us bringing this particular asteroid back, this is some of the most pristine material of asteroid sample that we have in our current collections.
And suck.
The Astromaterials Research and Exploration Science Division, or the ARES division, is a division within NASA that focuses on the study and preservation of rocks from space.
This is a group of a really diverse range of scientists and engineers that are exploring our solar system through studying samples, developing things like lunar simulants, being part of NASA missions that range from the exploration of Mars, including the Curiosity and Perseverance rover, supporting the Artemis missions, as well as OSIRIS-Rex.
We have meteorites that fall into Earth. They are altered by the Earth's atmosphere. They have been exposed to Earth's chemical compositions. They are contaminated samples.
And in our curation labs, we carefully work on samples in clean rooms, nitrogen atmosphere glove boxes that protect the samples from Earth's atmosphere, oxygen and humidity.
You don't want to study us on samples. You want to study the actual samples in its original state. And so pristinity within curation is very important, and we go to great lengths to make that happen.
Every time we do that kind of probing investigation, we learn something new about the nature of the universe and ourselves.
3, 2, 1.
And liftoff.
I feel like humans, since the beginning of time, have always been explorers. We have not stayed in one place. We have ventured out to various continents, and eventually that was going to happen with planets or asteroid bodies.
Whether it's Artemis or Mars, everything we've learned on OSIRIS-Rex is going to further our knowledge and our technology development for the next set of missions that we have coming up.
These samples are here on Earth for future generations. 50 years from now, we can be studying these with instruments we couldn't have imagined before. So I think that's one of the most important aspects of this mission, is bringing the samples back. We've waited for 7 years, and now we can reveal what's inside.
Cool. Very cool.
Next up is someone who needs little introduction. He leads our agency and keeps a close eye on our efforts across the solar system. Please join me in welcoming NASA Administrator, Senator Bill Nelson.
Senator Administrator Nelson. Well, thank you, Shaniqua, and thanks for being here today, everyone.
Hey, everybody. It's days like this that continue to amaze me.
Discovery, go at throttle up.
And what we do in this little agency, it's all amazing. I'm going back to the Cape this afternoon because we're launching a $1 billion spacecraft all the way beyond Mars, closer to Jupiter.
What's up,
and it's going to snuggle up next to a metallic asteroid.
Yeah, baby.
And we're going to learn something about that metallic asteroid. I hope we might find diamonds and rubies on that asteroid. But it's a reflection of our country, our can-do spirit. America is defined by possibilities. And we've always been a nation that is restless unless we're pressing the unknown. For 65 years of NASA's existence, and this is our birthday, NASA has responded to America's call. And the story of this little agency is the story of technologies transformed, of barriers broken, of making the impossible possible. And so through missions like what will be Psyche, the one lifting off tomorrow, or Perseverance, the rover that is running around on Mars and digging samples in our search for life there, or the little helicopter that's now flown upwards of 60 times.
They did.
We just wanted to see if a helicopter could fly in a 1% atmosphere.
They did helicopter on Mars.
It's flown 60 times.
60 times. See?
If it's the James Webb Space Telescope. Look at the discoveries. We are going to have answers to questions that we don't even know what the questions are now. Everything is a new discovery as we are glimpsing the early part of the development of this magnificent thing called the universe. And now, OSIRIS-Rex. And it's giving us a glimpse into what lies beyond. So 7 years, almost 4 billion miles of a journey throughout the solar system to the asteroid Bennu, now back. And OSIRIS-Rex, the sample return capsule, landed in Utah, right on the money. It was a picture-perfect mission. It's a feat of engineering, and it's NASA's first ever sample from an asteroid. So, you ready to see the results of the mission?
No. Yeah. Well, that's just a stupid boulder.
So the first analysis shows samples that contain abundant water in the form of hydrated clay minerals, and they contain carbon, and you could see the carbon there, as both minerals and organic molecules.
Okay.
And at nearly 5% carbon by weight, carbon being the central element of life, a far
5%.
exceeding our goal of 60 grams. This is the biggest carbon-rich asteroid sample ever returned to Earth. Carbon and water are molecules. The carbon and water molecules are exactly the kinds of material that we wanted to find. They are crucial elements in the formation of our own planet. And they're going to help us determine the origin of elements that could have led to life. And I mentioned that one of our missions, it's actually in statute, is to look for life. That's why we're digging on Mars. That's why we go out into the far regions of the very beginning, capturing light from the formation of the first galaxies with James Webb. Now we're looking at this, and what you're seeing today, there's so much more to learn, and there's so much more now that we have this sample to analyze. And why are we doing this? Because at NASA, we are trying to find out who we are, what we are, where we came from, what is our place in this vastness called the universe. And this mission will help our scientists investigate planet formation for generations to come. And it's going to deepen our understanding of our solar system. And it's going to improve our understanding of asteroids that could threaten us here on Earth, helping us protect our planet. And oh, by the way, do you remember DART? We intercepted it at 7 million miles away, and it was bullseye. And we moved the trajectory of that asteroid.
Dynamos?
So this sample return is proof.
No. Forgot the name, huh?
that NASA does big things. Things that inspire us and unite us. NASA brings us together.
They're nothing like
unity. And things that show that nothing is beyond our reach when we work together. So now I want to take you to the curation lab here at JSC, where a team of scientists are hard at work since the sample arrived just 2 weeks ago.
Thank you, Administrator Nelson. Now, I know you're all ready to learn more about this sample, and I am here with someone who can make that all happen. I am joined today by NASA's OSIRIS-Rex curation lead, Dr. Nicole Lunning, and we are standing just outside of the OSIRIS-Rex pristine curation clean room. Nicole, before we get started, can you tell us a little bit more about where we're standing right now?
Yeah, thank you, Courtney. So we're in front of the newest curation lab
Sorry,
in historic Building 31.
These folks talk at normal speed, so I gotta
which is home
slow it
to
down.
the largest collection of astromaterials in the world.
Now, the world just got its first look at this gorgeous sample. Can you tell us about how the curation process has been going so far?
Yeah, it's been incredible so far. On Sunday, September 24th, the sample return capsule landed safely in Utah, and then it was brought to a temporary clean room that we had set up there to have certain parts removed, specifically the heat shield and back shell, which are two large parts, and that exposed the sample canister inside, which a nitrogen flow or purge was attached to protect the sample. And then with that nitrogen flow attached, the next day, Monday, September 25th, it was flown from Utah to Ellington Air Force Base and brought here to Building 31 where we are now. And it was safely brought into one of our large glove boxes behind us that first day. The next day, our team was able to remove the canister lid, and that gave us our first glimpse of the TAGSAM head, but also a surprise in that there was sample outside of the TAGSAM head within that sample canister. That was kind of an extra or bonus sample for us.
Cool.
Well, what an honor to be standing right here, so close to the sample with you today. So you mentioned that bonus sample. What have the initial findings been for the curation team?
Yeah, it's a combination of fine dust as well as some what we call intermediate sized particles, particles that are roughly the size of the short width of a grain of rice, which we've carefully collected and also have already allocated some to the science team, the sample.
Any system of measurement but the metric system. Lateral grains of rice. Anything but the metric system.
Analysis team, which you'll hear a little bit more about from Dante and Danny in the quick look analyses.
And of course, this is not just a NASA mission. There have been several partners along the way. Can you tell us a little bit more about how many scientists are working on this?
Yeah, so we have two incredible international partners, JAXA and CSA, and also the sample analysis team includes over 230 scientists from around the world who will really intensely work on studying some of the sample for the next 2 years. We'll also have 3 samples go to museums in the next couple months. So folks at home may have the opportunity to go and see the sample themselves at the Smithsonian in Washington, D.C., the University of Arizona Museum in Tucson, or at Space Center Houston right here in Texas.
Cool.
So exciting. So what does it mean for your team to have seen this clean room built from the ground up and now to see the sample in it? I'm sure it has to be so exciting.
Oh, it's incredible. So this clean room was constructed very specifically for the OSIRIS-Rex sample. Since the scientific goals of this mission are really tied to the building blocks of life and organics, organic contamination was a really detailed concern to us throughout the entire design and construction process and outfitting. So everything you see in this lab was carefully reviewed to make sure it wouldn't contaminate the sample so we can get the most scientific benefit out of this return.
So can you tell us a little bit about how long it will take to fully reveal the sample and where the sample will live?
Yeah, so the sample's permanent home is this lab behind us. But what will actually happen next is we'll continue taking the TAGSAM apart. So right now we have this incredible view of the sample into the TAGSAM. We're looking into the part that touched the asteroid Bennu. We're actually going to take those parts off to get a little further in so that we can then distribute that sample into bulk sample handling trays, which are triangular and look sort of like deep dish pizzas.
And for scientists interested, how will they eventually be able to request a sample?
Pizza?
So in about 6 months, we will release a sample catalog, which will give scientists from all around, even beyond the sample analysis team, enough information to start to think about what science questions they want to ask, and they can propose studies and specific quantities of sample they would like to use. And then those requests will be reviewed by a peer review allocation board.
and then those who are granted their requests will get samples in the next 9 months or so.
All right, well, Nicole, thank you so much for joining us today. And as you can see, we are just beginning this process here at Johnson Space Center, but there is much more work to do. So we'll send it back to the auditorium for now.
So those samples are from the asteroid Bennu, which is, it's pretty much in the outer rim of our solar system. There's asteroids that are beyond Mars's orbit between us and the gas giants. There's a big asteroid field. A big asteroid field. So Bennu was a target for the OSIRIS-Rex mission. They launched it in 2016, and it made it out to Bennu in 2018. And what the thing, that's the spacecraft over there. What it did was orbit around Bennu. Bennu is it's probably like, I don't know, like 400 meters in diameter. It's not very big, but it is big enough to have a gravitational pull. So it's, you know, not as big as your mom, but still pretty big. So what OSIRIS-Rex, for the most part, did was they mapped the asteroid first of all. It was because it was orbiting around it. It was in a polar orbit around Bennu. They mapped it, and then OSIRIS-Rex has a little robotic arm on it. And that little robotic arm basically had a vacuum cleaner with a canister at the end, called the TAGSAM, and it basically, they deorbited it around Bennu and went and popped the asteroid. They booped it for a second. And the TAGSAM is basically a vacuum cleaner. It'll basically suck up it basically sucked up some of the asteroid samples. The reason why NASA chose to make a vacuum cleaner is because of the low gravity. I mean, if you went there and you tried to dig a hole, right? The force imparted on you pushing the shovel or pushing like a robotic arm with a scoop into the ground of Bennu would actually push you on escape velocity out of the asteroid. So they basically got really close to it, basically rendezvoused with the thing, and when it got real close, the vacuum sucked everything up. That was the only way to get a good sample, because once again, if you try to reach out and grab the thing, you're going to push yourself out of its orbit. Don't want that. So the TAGSAM had a little canister, and it had a vacuum cleaner attached to it on the end of OSIRIS-Rex's arm, and it sucked it up, right? And then from there, they took the TAGSAM and they put it in a capsule. You can kind of see the top of it up there. They put it in a capsule, and OSIRIS-Rex actually pooped it out, and it was on a return trajectory with Earth. It landed a couple of weeks ago out in the Utah desert. And these are the samples that they got from it. It's a long mission. Long freaking mission. But they found carbon, NASA found carbon compounds and water in those samples. Now, water's pretty cool. Carbon compounds are pretty cool. Why is that significant? Well, this thing is not near us, and it has stuff that's similar to Earth on it. That's why that's kind of significant. That Bennu is not near us. It's a long way away, further away than Mars. It's really in the outer rim of the solar system almost. But it has similar things on it that allowed life to flourish here on Earth. That's why that's pretty damn significant. Yeah, near is relative. I mean, it's still a long ways away, guys. It's nowhere near Earth, like on a scale that we understand. I mean, I suppose on a solar system scale, it's actually closer than you might think. But the fact that there's stuff that's similar to Earth on an asteroid that's floating not near Earth is pretty interesting. Bennu is aligned with Earth's orbit. Well, I mean, once again, not near us. I mean, comes near us every once in a while, but not near us. It's a long way away. Anyway, that's why it's significant, because they found stuff that is very similar to Earth, to the composition that NASA believes allowed life to flourish here on Earth. They found it on an asteroid. So that That raises some interesting questions into planetary formation and planetary geology around the solar system. Well, if this stuff has stuff that's similar to Earth, why? How did that happen? Maybe Bennu is the remnants of a big asteroid that hit Earth and deposited minerals on Earth and building blocks here for life. It's possible. Maybe it was part of the moon and the moon crashed into Earth. Who knows?
After its 7-year journey, it's amazing to finally see a glimpse of the samples that were captured from asteroid Bennu. Not only will this mission help us dive deeper into how planets formed and how life began, it also will allow for current and future scientists to make discoveries for years to come. Now, to help us take a closer look into what we've learned so far, we have a panel of individuals who played key roles in the OSIRIS-Rex mission. Please welcome back NASA Administrator Bill Nelson.
Well, thank you, Shaniqua. I really appreciate it.
OSIRIS-Rex Principal Investigator, Professor Dante Loretta. OSIRIS-Rex Astro Materials Curator, Dr. Francis McCubbin. Goddard Space Flight Center Sample Analyst, Dr. Daniel Glavin. And Director of the Planetary Science Division, Dr. Lori Glaze.
And of course, Hernandez.
I know you all have a lot to say, so let's get started. Administrator Nelson, let's start with you.
Well, this is an example of why we do make the impossible possible. It's a team that no matter where we are, we all work together. You all know Pam Melroy and Bob Cabana.
Yeah, Boz, that's cool,
and
man.
We, the three of us, operate as a crew. It's because of that unity, that relationship, that watching each other's back, that we get so much done. And here is another example of what you've seen today. Now, I want you all to hear from the real experts. So take it away, panel.
Thank you, Administrator Nelson. Next up, we have Dr. Francis McCubbin, Astro Materials Curator.
Thanks, everyone. So we are thrilled to have the OSIRIS-Rex sample collection here at NASA's Johnson Space Center. And we look forward to the exciting discoveries that are going to be made by the science team with those samples. Over the next 6 months, the curation team and the science team are going to be working closely together to develop a sample catalog that, once released, will provide an opportunity for scientists around the world to request material to study Bennu in their own labs. For now, the curation team is hard at work, carefully and meticulously disassembling the hardware, containerizing asteroid material, and documenting everything they do every step of the way. All of this work takes place inside of a glove box. And those glove boxes are necessary to keep these samples as pristine as the day that the sample landed in Utah. Now, as you've heard, we have a bounty of sample on our hands already, and we're not even inside of TAGSAM. The views here are amazing of this sample, and they're only going to get better. Now, as you can imagine, working with hands inside of a glove box within a clean lab is hard, challenging work, and it does not go quickly. But we need to do this right. And in fact, we have a lot of heritage of this working really well to keep samples pristine over multi-decadal timescales. If we just look at our Apollo collection, the samples that were returned in the late 60s and early 70s when humans first went to the moon, to this day, we still get hundreds of sample requests and allocate hundreds of samples to answer questions that we didn't even think to ask at the time that those samples were returned. This is the true value of sample return and of curation and keeping these samples pristine. It allows us to answer questions that would not be possible with the technology of the time. In fact, like all of our astromaterials collections, the OSIRIS-Rex collection is going to be conserved so that scientists that aren't even born yet are going to have the opportunity to answer questions about our universe with these samples using technology that has not even been invented. This is the legacy of OSIRIS-Rex, end of sample return broadly. And now let's hear some of those science results from the science team.
Thank you, Francis. Next up.
I like that guy. That guy's cool.
Great job, Francis. Next up, we have Professor Dante Loretta, the principal investigator for the OSIRIS-Rex program.
All right, thank you, Shaniqua, and thank you, Administrator Nelson, and to Dr. McCubbin. I just want to start out by saying what an honor it is to be on stage here talking about the amazing results. And I want to talk to the young people in the audience, because NASA for me when I was a kid was always like a guiding light, like a dream. To work for NASA meant to be part of the best, to be at the forefront of human exploration. And to see this dream coming true today is beyond words for me. So let's start out with taking a look at what we've gotten into so far. As Francis said, it's been going slow and meticulous, but the science is already starting. So if we could bring up my first graphic. So what you're seeing here on the left side is the first look at the tag SAM. So you've got the science canister, that's like the vault that protected the sample on the return journey home. And sitting inside there is the tag SAM. That's the device that actually touched the surface of Bennu, collected sample, kind of like a vacuum cleaner, except in reverse, because we were in space with no air. We brought our own air, and pushed that material inside. It's basically like an air filter. And the first thing we noticed was that there was black dust and particles all around the outer edge where the seal had laid down and protected that precious material. And the reason it got pushed out was because we had under that nitrogen purge to keep it, the Earth's atmosphere away from it, and it pushed all the dust and particles to the edge of the canister. And I drew a little white rectangle there on the deck, and that's zoomed in on the image on the right there. And already this is scientific treasure. We see dust particles and we see millimeter particles, which are like a 1/16 of an inch or so in size. And we swept some of that material and we got it to the sample analysis, what I called my Tiger team. They were here at Johnson Space Center. The electron microscopes were fired up and ready. All the other instruments were ready to go. And we got those particles in on the third day that we had the sample here in Houston on September 27th. So let's take a look at some of the first results that we got from those particles. And boy, did we really nail it. So here I'm just showing you 4 different examples. This is taken with an electron microscope. Electrons kind of behave like light waves, but they have much shorter wavelengths, so you can see very, very fine details that you would never be able to see with an optical microscope. The first panel there in the upper left, those are the water-bearing clay minerals, and they have this fibrous kind of structure. We call this serpentine because they look like serpents or snakes inside the sample. And they have water locked inside their crystal structure. And I want to stop and think about what that means. That water, that is how we think water got to the Earth. The reason that Earth is a habitable world, that we have oceans and lakes and rivers and rain, is because these clay minerals like the ones we're seeing from Bennu, landed on Earth 4 billion years ago to 4.5 billion years ago, making our world habitable. So we're seeing the way that water got incorporated into solid material and then ultimately into planets. And not just Earth, but probably Venus and Mars also had abundant water as well. The next one on the upper right, you can see the hexagon. It's got that really like stop sign kind of shape. And that's characteristic of a sulfide mineral. If we could go back, yes, thank you. And sulfur is also a critical element for planetary evolution. It determines how quickly things melt, and it's also critical for biology. A lot of the amino acids that give structure to our proteins use sulfur to link and provide those bridges. And then the bottom 2 there are iron oxide minerals called magnetite, or you might know them as a lodestone. They react to the magnetic fields. The one on the lower left is framboidal, like a raspberry, and the one on the right are plate-like. And especially those platey ones might be really important for organic evolution. They might catalyze certain reactions. So we're looking at the kinds of minerals that may have played essential roles in the origin of life on Earth. Now we can go to the next graphic. One of the coolest techniques that we have here at Johnson Space Center is X-ray computed tomography. It's like a CAT scan. So without cutting into the rock, we can actually look inside. We can see the textures and the distributions of the minerals. This helps us intelligently select areas where we want to make cuts so that we get the most exciting science results. It also gives us a good sense of the size and shape of the particle. This is the biggest one. It's about 2 millimeters across. And you can see here in red those sulfide minerals. I'm particularly fond of those. I'm an expert in sulfide mineralogy, and I can't wait to get inside and look in great detail at what's going on here. And now let's go to the last graphic. We saw Administrator Nelson show you this. I just want to point out a couple of my favorite features. Trust me, I spent the weekend staring at this image for hours and hours and getting more excited by the day. I've got 4 different focus boxes. Let's take a look at B. I call this one of the troublemakers. If you know the story of OSIRIS-Rex, you know just a couple days after we collected the sample, we saw material spewing out into outer space. One of the many heart-pounding moments on this mission for me. It's because these large particles got trapped in between this flap, which was designed to keep the precious sample inside. And that's generally good news, right? Because those are big particles, and there's a lot of science to be done there. In panel C, we're just looking at some of the finer grain material, and I'm particularly interested in the different reflectance. Bennu has a salt and pepper kind of texture, bright grains and dark grains, and we're seeing that. In fact, as I was zooming around these images, I felt like I was miniaturized and running around on a tiny little Bennu. Panel D there is one of the really friable looking particles. It's got this kind of hummocky texture. It looks like the dark, large boulders that dominate the surface of the asteroid. And what gets me is the similar size and the similar shapes and textures, even as we go to these smaller sizes. Bennu seems to have this kind of fractal nature. And then finally, the last panel there, panel E, just shows 2 very different kinds of rocks sitting next to each other. One of our key hypotheses is that there's 2 major different kinds of rocks on the surface of the asteroid, darker and brighter, weaker and stronger. And we may see those already represented. And just recall, this is the material that leaked out of the tag SEM when we flipped it over. Underneath that flap, there's a whole treasure chest of extraterrestrial material, and trust me, the sample science team can't wait to get their hands on it.
Thank you, Dr. Loretta. Now let's hear from Dr. Daniel Glavin, OSIRIS-Rex sample analyst.
This guy's cool.
Okay, thank you. So we've heard a lot of exciting stuff already about the water and how Bennu could possibly contribute to our oceans. I'm here to talk about carbon. Why is carbon so important? Well, carbon is essential for all life on Earth. We are all carbon-based. Carbon forms bonds with hydrogen, oxygen, nitrogen, and the sulfur to form prebiotic and biological compounds that are important, amino acids that are part of our proteins and enzymes. We even look for nucleobases, components of the genetic code in DNA and RNA.
Cool.
So exciting stuff. And one of the reasons we want to look for this material in these samples is to understand whether asteroids like Bennu could have not only delivered the water that led to our oceans, but actually seed the Earth with prebiotic chemicals, right? The building blocks of life. And this is the part I just find really exciting. So let's get right to it. The first carbon measurement was made at the Carnegie Institution for Science. We heard it from NASA Administrator, about 5%. The actual number is 4.7%, close to 5%. And this was a big deal. At the time this data came back, I mean, there were scientists on the team going, wow, oh my God.
That's a
and
lot.
When they say
that's a lot.
Scientist says that, wow, that's a big deal. So we were excited right away. In fact, Carnegie said this for the extraterrestrial samples they've analyzed, this is the highest abundance of carbon they've ever measured in any extraterrestrial sample. And they've analyzed close to 250 meteorites. So this is a unique sample that we're dealing with. The second measurement we made, we started to look more at what is the nature of this carbon. You're looking at an image here.
Jordan?
Oh my gosh, this was taken in the optical microscopy lab right here at Johnson Space Center. Gorgeous image of a particle of Bennu. On the left, you see a small grain of Bennu in reflected light, visible light, like you'd see with your eye, but magnified. And on the right, you see the same grain, but under UV ultraviolet light. So this is like the crime scene investigation TV show where they go in with the black light and they look for the evidence that they can't see with their naked eye. We're doing the same thing here now, but with a 4.5 billion year old grain from the early solar system. And the stuff's lighting up. You see carbon there in the center, just to the right, the kind of a light bluish fluorescence. That's from a carbonate mineral, so carbon locked up in this mineral grain. But then you see these small specks of light, looks like stars, right, glowing. This is organic matter. Call these organic globules. And I know the analyst at the time who made this measurement said, you know, this thing's loaded with organics. I mean, again, just, you know, this is incredible material. Still a lot of work to do, and we're just beginning here. We're just literally scratching the surface of what's in this material. But we'll be looking for these, again, biologically essential organic molecules over the next month as these samples will go out to labs around the world to study this in more detail. And I want to make just kind of one final point. We've heard about these great initial preliminary results. I know there's more to come. But OSIRIS-Rex, the team, we picked the right asteroid. And not only that, we brought back the right sample, right? This stuff is an astrobiologist's dream. You know, just can't wait to get at it. And this material will be around for generations and generations. We're going to learn so much about the origin of the solar system, the evolution, and potentially how even life started here on Earth.
That was 2018 Be There guy. That was for the people that were here when OSIRIS-Rex launched. Remember 2018 Be There. That was that dude. Glavin.
Next up,
which
and
is
finally,
cool.
we'll hear from Dr. Lori Glaze, Planetary Science Division Director.
Thank you, Shaniqua. It's such an honor to be here today, and what an incredible honor to share the stage with these amazing scientists up here. You know, we're just, you know, within NASA, we're so proud of everything that is gone on so far with this mission. We're so excited for everything yet to come. But I want to note, you know, just beyond the folks that are here, the folks that you saw working in the lab, there's a whole team that's been spending incredible hours over the last 2 weeks to bring you the information that you saw today and to make these early discoveries. It's just an incredible team. They're working really hard, and you know, we keep telling them, you know, take your time, go slow, but they're doing an amazing job. It's really incredible. But as you heard, what you're seeing here today, as exciting as this is really just the beginning. There is so much incredible work to happen. We're going to get that tag SAM opened up. We're going to get the full sample. We'll really get a full picture of what we collected and begin those amazing discoveries. But let me put OSIRIS-Rex in a little bit of context about some of the other planetary work that we're doing at NASA. So within our NASA planetary program, we actually have almost 40 missions that are exploring the solar system. Some of those are being developed, some of those are in operations. But within those almost 40 missions, we actually have 7 of those missions that are focused on understanding asteroids. And you heard from Dante about how important asteroids are for understanding the early formation of our solar system, the origin of life and water on Earth, and perhaps other places in the solar system. These asteroids are really, each one of them in different parts of the solar system can give us different pieces of the puzzle about where we came from. And of those 7 missions, right now, we're really lucky because we're in the middle of what we're calling asteroid autumn. We've got several big milestones happening right now on 4 of those missions. Of course, you know we got the OSIRIS-Rex sample that landed on September 24th. Right after, 20 minutes after the entry system was released from the spacecraft, we actually transitioned that spacecraft for a new mission. It's now called OSIRIS-Apex. And that's a mission to go explore the Apophis asteroid. We're actually going to rendezvous with Apophis in 2029, so they've got another long journey and another great goal for that spacecraft.
Cool.
And then 2 days after the OSIRIS-Rex samples landed in Utah, we celebrated the 1-year anniversary of the double asteroid redirection test.
Dark.
And you heard Senator Nelson at the beginning mention that. What an incredible feat that was. The first time ever for humanity to change the orbit of a celestial body. And the first time we've demonstrated our ability to protect ourselves from a potentially hazardous asteroid in the future. So now we're celebrating OSIRIS-Rex here today, the sample reveal. And then coming up in November 1st, we have another mission that's going to explore a special set of asteroids that are even much further out in the solar system. They lead and trail Jupiter in its orbit around the sun, and those are called Trojan asteroids. That mission, called Lucy, is actually on November 1st going to fly by a main belt asteroid on its way out towards the Jupiter system. And it's going to fly by a main belt asteroid called Dinkinesh, and it's going to allow them to test out all of their operations as they fly by the asteroid. And then finally, the big one that Administrator Nelson also mentioned is that we have a mission called Psyche going to visit a unique asteroid, one of only 9 out of several million asteroids that we believe are out there. There's only about 9 or so that we've discovered so far that we think are really enriched in metal, iron and nickel. And so the Psyche mission is going to go visit that asteroid, 16 Psyche, and we hope to launch it tomorrow. In fact, I'm getting on a plane this afternoon to go back to Florida to hopefully wish it off the surface of Earth tomorrow, but we've got so many opportunities for that to happen. And so that's the next big thing. Pay attention for that one. And with that, I'm going to hand it back to Shaniqua.
Thank you. Thank you, panelists. We will now move on to our Q&A segment. We'll be taking questions from media in the room and students from the Houston and San Antonio Independent School Districts. We'll take our first question from media. If you'll come to the mic one at a time, you'll be able to state your name and affiliation, and if you know where your question is going, please direct it to one of our panelists.
Hi, I'm Andrea Leinfelder of the Houston Chronicle. I have a question about the TAG-SAM. Did you guys expect it to be open by now, and has there been any reason it's not open? Have you run into any problems or anything that just made the process slower than expected?
They already
Thank you.
said why.
So the only problem is a great problem, and that's we found a lot more sample than we were anticipating before even getting into the TAG-SAM, and because we need to very meticulously and carefully collect every grain, it's taking us a little longer to get inside, but the view so far is amazing.
Not a bad problem to have.
Our next question we'll take from students. If you come up to the mic and tell us your name, grade, and school, we'll like to hear from you.
Hello. I don't think hello. Oh. Hello, I'm Allison Cordova. I'm in 6th grade from D Middle School, and my question is, do you think the samples got affected from the heat when entering our atmosphere?
I'll take that one. No, because the sample return capsule, you can see our engineering model. So this is what we did all of our practice with. That white nose there is a heat shield. And it's made of very special material that protects the sample inside. And one way to think about it is when the astronauts come back from the space station or from the moon, they have a similar kind of capsule. The astronauts land safely, just like the sample did. So that heat shield took all of the heat through the passage through the atmosphere, keeping that sample pristine and safe inside.
Thank you.
Thank you. We'll take our next media question.
Hi, Eric Berger with Ars Technica. Congratulations, those were some pretty stunning images of what we saw. I guess my question is for Dante Loretta. Just, I know you haven't opened up the TAG-SAM to look at all the rocks and hopefully inside, but I'm sure you've done a mass analysis of the spacecraft versus, you know, what you've got now. And so I'm just, what is the estimate of the total amount collected versus the minimum goal of 60 grams?
Fair question.
Great, thanks, Eric. Great to see you here. So we were able to do a mass estimate in flight, and that's not an easy thing because you're in a weightless environment, right? You're in microgravity around the asteroid. But TAG-SAM, the filter, was at the end of a long robotic arm, about 9 feet long. And as we moved that arm before sampling and after sampling, we were able to look at a property called momentum that was transferred between the arm and the spacecraft. There's special components called reaction wheels, which will take up that momentum. And we looked at that difference, and we estimated about 250 grams or about 8.8 ounces of material. So we're hopeful about 4 times the mission requirement is still to be revealed inside TAG-SAM.
Great.
But of course, the proof will be when we open it up and we actually get it on a balance here in our Earth's gravity field and get that real number for you.
All right. We'll take our next student question.
Very nice.
Hello, I'm Raj Sinha from Houston, Texas. I am a junior at Langham Creek High School and a NASA SEAS high school intern. And this is a question for anyone. What are the broader implications of the OSIRIS-Rex mission for our understanding of asteroids, the early solar system, and potentially hazardous space objects?
Very good question. It's a very good question. Sweet.
Well, you think about the formation of the universe and then the formation of our solar system. And there's this gas and this dust that's all swirling, and things start to be created, and then all of these things start running into each other, and out of it come stars, and then lesser celestial bodies start getting within the gravitational pull of that star, but there are still these particles that are running through space that are ramming into each other. That is going to be the clue for us examining an asteroid like this and the others that Lori Glaze mentioned, as we try to understand those questions that I posed when I was up there at the microphone. Who are we? How did we get here? Where are we in the vastness of this cosmos? And this, by the way, is fulfilling part of our destiny. And part of our destiny is that we are explorers. We are adventurers. We want to know what's over there in order to know why we're here.
That didn't answer the question at all. What's the broader implications of OSIRIS-Rex? We're explorers. All right. Maybe Asmalak, who knows? Bill loves the big questions like this. That's part of why I like him. I mean... he's, let's see if the scientists have the...
All right, we'll take our next media question, please.
No.
Hi, I'm Mike Prokosh. I'm with the NASA Social and Sam Houston State University. And I was wondering, how did the rotation rate of the asteroid influence the choice of the landing zone?
Great question. So one of the criteria when we selected the target for the mission was its rotation rate, because if an asteroid is spinning too quickly, being able to match that velocity and make a safe contact with the surface would have been impossible or really, really difficult. So it was originally, when we were going through the millions of asteroids that Lori mentioned, to pick the one that you send the spacecraft to, the rotation rate was important. The surface is moving about 10 centimeters per second, so just a few inches per second, so really slow relative to what we can do with the spacecraft. And at the end, right before we sampled, we had to match that rotation. It was the final maneuver we called the match point. So we were essentially hovering over the sampling location, and the spacecraft just dropped down for that gentle contact to collect the material.
All right, we'll go to our student question. Again, please state your name, grade, and what school you attend.
My name is James Johnston. I'm a senior in high school, and I go to CETA High School at Roosevelt in San Antonio. And my question is, where did the Bennu asteroid come from?
Where did Bennu come from? Maybe it's a Danny.
It's a great question. That's what we're trying to figure out. Certainly we think, originally it was part of a much bigger parent body, probably 100 kilometer, somewhere in the asteroid belt, maybe towards the outer parts of the asteroid belt, and then was broken apart, right, by an impact, and we're looking at kind of the remnants of that, a rubble pile, if you will. So some of those pieces came back together, and then it ended up, kind of in this near-Earth orbit. But we're trying to figure out really the history of that process, when those things happened, where it originated. That's part of our major science goals here, and by studying these samples, we're going to be able to answer that question in more detail than I can give you right now.
All right, next media question.
Hi, Kaylee Brower with NASA Social and Harvard Smithsonian. I was curious about the appeal of the larger rock samples, such as the one trapped under the flap on the canister, versus the smaller dust and rock samples.
Yeah, I'll take that. So we're excited about the whole size range of what we see there, because that'll tell us about the different formation mechanisms of the stones. So the big ones are really good because you get the minerals in context to each other, which mineral is next to which one. That'll give you some indication of the chemistry that happened inside the asteroid. Minerals will convert when the water hits them. You take a normal rock and you add water and you get the clays. And we might even see the original rock inside, and that where the water was reacting, and that might be frozen. So it gives you that context and that big picture. The fine particles I'm particularly excited about because I think they were bigger stones when they were on Bennu in the microgravity environment, and then when they got to Earth's gravity, it just crushed and fell.
Oh,
and
dude.
Something like that would not make it to the surface of the Earth as a meteorite.
No
and
way.
So that, to me, as I grew up studying meteorites, in college and in graduate school, so to have something from space that we've never seen in our laboratories, there's nothing more exciting. No matter what it is, the fact that it's new has got us really anxious to get that material into our instruments.
All right,
That's a good
we'll take
question.
another student question.
Hello, I am Aaron Kingsland from Lavernia, Texas, a junior at Idea Carver College Preparatory School and the NASA SEAS high school intern. My question is, what ripple effects do you anticipate the OSIRIS-Rex accomplishment will provide for both space exploration and our world, given the historical precedent of space achievements driving unexpected advancements in various fields?
Putting up back to Bill. Here, let me speed it up.
At NASA, we're doing 100 things at once. And this is just one example. Dr. Glaze mentioned a whole bunch of others, but we haven't even talked about what is one of the primary purposes of the Johnson Space Center, which is human spaceflight. Look at the breakthroughs that are coming now, finally coming to fruition in pharmaceutical research on the International Space Station. It's just unbelievable. Now we are going back to the moon after a half century, not just to go to the moon. We're going back to the moon in order to learn, to live, to create, to invent, in order to go to Mars and then beyond with human beings. Again, it's part of our nature as adventurers, as discoverers. And by the way, this didn't just start with us. We happen to be a new world that happened to have a European discoverer experience it. But before that were the indigenous peoples, and they discovered. So somewhere deep inside our core is this yearning to learn what's out there.
What?
Now, we are playing the discovery in such a large, large playfield called the universe. And we find from James Webb, we find that after a NASA scientist who got the Nobel Prize, by the way, discovered that the universe is 13.8 billion years, we are beginning to see that light as a result of the telescope. 1 million miles from Earth, we're beginning to see that light in the formation of that first galaxy. So there's still so much more to discover. What? And you're going to be part of it. And by the way, you're one of our high school interns. You keep at it.
Thank you. What just happened? All right.
All right, we'll take another one from media.
Hi, Robert Perlman with CollectSpace and Space.com.
Ron Perlman. Wait, no.
3 samples or some amount of samples are going to be going to 3 museums for the public to see and sharing the excitement of this. Can you explain a little bit, given how there's an apparent excitement about even the smallest samples, how you go about picking what to send to a museum or what to give to JAXA, what to give to CSA? How are you going to divide the sample?
By height?
Yep, so I can take that one. So once we get inside of TAGSAM and get a real idea of what's there, we've got processes set up where representatives from the Space Agency and JAXA are going to come and look at the sample along with the team. And as a team, we're going to look at everything and basically pick out which materials. The amount of materials already been decided, but picking out exactly which material is a process that we get to once we have TAGSAM open. And it's, you know, everyone basically in the lab looking at the material directly. And for the museums, those materials get selected in combination with the science team and curation. Basically, what, you know, we don't want to take anything that's going to have the most scientific value, so we're looking for things that we have more than one of. Usually we want at least 4 of any type of thing before we start using it for something else. And those are the samples that are going to go to the museums, and they're going to be amazing. I can't wait to have the public get an opportunity to look at these beautiful samples.
All right, let's go to our next student.
Hi, my name is Kylie Mays, and I'm from DD Middle School, and I want to ask, what does Bennu mean, and why did you pick Bennu from all the other asteroids?
I'll take that one. So we picked Bennu as the target of this mission all the way back in 2005. Just gives you an idea how long I've been working on this program. And the first set of criteria were based on engineering. We wanted something basically that was a near-Earth asteroid. You know, originally we thought we would go out to the asteroid belt like the Psyche mission is going to do and get a sample and bring it back, but that was going to take a couple decades. And you know, as long as I've been working on this, I wanted to try to make it as efficient as possible. We didn't want to get too close to the sun because things get really hot, like the Parker Solar Probe has all kinds of special equipment to survive touching the surface of the sun. We didn't want to have to deal with that on OSIRIS-Rex because it's expensive and complicated, so we didn't want to get too much farther than the Earth is. And we didn't want to get too far away because we needed solar power. The spacecraft is completely solar powered, and the farther away you go, the bigger those solar panels need to be. Look at Psyche again, or the Juno mission. They're giant, and that makes it hard to do the precision maneuvering. And then we're bringing this capsule back, and we couldn't come in too fast, so we needed an asteroid whose orbit would allow us to come in slow enough that that heat shield could protect the sample. After all of the engineering was done, we went to the size. We wanted something kind of big because we thought it'd have a better chance of having loose material on the surface. And then finally, science got to come in and say, we want the carbon. Carbon is the #1 goal of this mission. And so we picked the asteroid we hoped had the most chance of being carbon rich. And as you heard from Dr. Glavin, that's exactly what we got.
Cool.
All right, we'll take another one from media.
Thank you, Mark Carreau with Aviation Week and Space Technology. Have you estimated the mass of the material outside the TAGSAM that you've assessed so far? And is that part of the overall 250 grams, or is that separate, additional?
Yep. So for what we weighed so far on the material from the avionics deck, we're just under 1.5 grams of material. We haven't weighed the material that's sitting on top of the Mylar flap with all the beautiful images that you've seen today.
That was me.
And the thing with the
I just kicked
particles
over
that we've
something.
measured so far, some of the larger ones weighed less than we thought, and some of the smaller ones weighed more than we thought. And so it's really hard to estimate the mass based on what we can see, but what I can tell you is that I'm very excited about the volume of sample that we can see now.
I'm sorry.
Thank you. Our next student question.
Hello, my name is Brendan Cody. I am an 8th grader at Kruger Middle School. My question is, will the samples of Bennu give us any
Kick the
advantages?
bucket, I kicked the flex plate. It's different.
That's an interesting way to phrase the question. I think that as humanity, yes, it will give us advantages in the sense that, you know, it's knowledge, right? The more we learn, the more questions we have, and it drives our purpose for future exploration. And I think that's for all of humanity. And I don't, you know, you've heard we have some amazing international partners on this mission, so it's not just the United States. This is an international endeavor. You've heard that the samples, our sample team, just the science team, is made up of over 200 people in 35 nations. So we've got an incredible, spread of this knowledge, I think. And then we'll also, as you heard, we're going to have a catalog that'll be open to the entire world to study those samples. So to me, the advantage that we have is really just in the knowledge that we're all going to gain.
Thank you.
Mm-hmm. All right, well, next up for media, please.
Hi. Hello.
No.
Hi. My name is Rindell Papa. I'm with NASA Social. First, thank you for all your insights and hard efforts over these past 12 years. Regarding the landing site for Nightingale, there was a surprising impact and shift. So has that determined or adjusted your impact for how you're going to select asteroid missions in the future?
Do you want me to take that one? I think that was one of the most amazing things, right, about Bennu. Number one is that it just kept surprising us and surprising us and surprising us. So the fact that when we went to take the sample, that, you know, when you see the animations and you actually see the video, real-time video of the descent, it just kept going. We expected there to be some resistance, and it wasn't there. And so that really tells us a lot about kind of the physical properties of this type of what we call a rubble pile asteroid. And that's really important as we start thinking about future planetary defense missions. So we talked about the DART mission, the Double Asteroid Redirection Test mission. As we start to look at asteroids that are potentially hazardous, one of the things we really want to know is it a dense, you know, monolithic rock, or is it just this loose collection of debris? And having the physical properties that we've gotten from Bennu will really help us understand and think about how we model what the potential dangers could be from asteroids. We've actually learned an incredible amount from Bennu that's going to help us in defending our planet in the future.
Awesome, thank you.
She has minimal flare. She
We'll
wants to
go to
express
another
herself,
student.
okay? And if she thinks that wearing
Hello.
3 pieces of flare is enough, then that's okay. Pajamas. But all I'm saying is that we at NASA encourage more flare, and we want you to express yourself. So keep on it with your flare. Do it.
Well, my name is Michael Alexander Cruz. I am from the district HISD. My school is Deddy Middle School. My question is, how big is the team that built and designed OSIRIS-Rex?
Good question, Mikey.
Take that one. One of the most amazing things about leading a program like this is the team, and it makes it all worthwhile. We've heard it many times from the administrator, from Dr. Glaze, that it's the team that really makes these missions succeed. And quite honestly, it's the best part of being a part of a program like this, because it's much bigger than any one person. I can tell you at the peak when we were building the spacecraft back in 2015, there were over 450 people full-time on the program that were paid right off the OSIRIS-Rex contracts. That doesn't count the subcontractors, the suppliers, the launch vehicle was separate, and now we have over 200 people on the sample analysis team. So easily over 1,000 people have worked on this, and probably many more. And I'm enormously grateful for every one of their efforts. We are all OSIRIS-Rex. Doesn't matter where you come from, if you're NASA, if you're Lockheed Martin, or University of Arizona.
We are all
we have
OREX
one unifying
on this
identity,
blessed
and that is
day.
OSIRIS-Rex.
Thank you.
Sorry.
All right, we'll go to our next media question. Please remember to state your name and affiliation.
Hi, my name's Josiah Horniman with NASA Social. You showed us some incredible images from the electron microscopy of different minerals. The iron oxide and magnetite in particular were very cool. Is there any planned analysis of the magnetic fields that might be frozen in those? And if so, are there any results there that might excite you?
That's a really important question, because I know there are a lot of scientists that are interested in possibly recording magnetic fields. One of the challenges is that there was a motor on the wrist of the TAGSAM that moved the head to position it for sampling and then for stow and for photography. And that's going to imprint a magnetic field on top of the sample. So we did not maintain magnetic cleanliness. When you're going through a program like this, you have to trade different things, and trying to keep the sample magnetically clean we deemed not within the resources that we had available for the program. So the sample analysis plan that we produced does not have magnetic field measurements, but as we've heard, in just a few short months, these are going to be available to the whole world, and I'm sure there's people that are smarter than me that know how to overcome the magnetic issues that were the result of the spacecraft design, and we'll go after that problem. But it's not part of our initial sample analysis plan.
Thank you. All right, we'll go to the next student question.
Hi, my name is Tadeo Garcia. I'm from Didi Middle School, and my question is, ¿cómo consiguieron con el nombre de OSIRIS-Rex? How did they come up with
the name.
OSIRIS-Rex name?
Como
Take
the
that one's
nombre
my
de
fault.
OSIRIS-Rex.
Okay.
How did they come up with the name?
But when I was first invited onto this program in 2004 by my mentor, Professor Michael Drake, who was the director of my laboratory, and I was just a young assistant professor, really didn't know what I was getting into. But what Mike said was, Dante, I want you to lead the science on this program. And he said he would deal with NASA and the government and administrators and budgets and all that stuff that I ended up doing. But the early promise was that I was going to be in charge of the science, and I wrote down 4 words that I thought captured the essence of asteroid exploration. Origins, because we're interested in the origin of life, the origin of the Earth as a habitable world, and the origin of our solar system. Spectroscopy, because we study asteroids mostly with telescopes, and spectroscopy is what happens when you take light and you break it like through a prism into its different colors, and the way it reflects at each color tells you about the minerals on the surface. And by bringing a sample back, we can tell, did we get it right or not? And by the way, we did. We predicted clay minerals, iron oxides, carbon-rich minerals, and organics from our spectral instruments on the spacecraft, and we've seen all of those already in the sample.
That's cool.
Then
man.
I wrote down resources, because I was thinking, I'm a science fiction fan, I'm thinking asteroid mining, maybe somebody will use the OSIRIS-Rex information to go and start furthering human exploration by using the resources that are there in outer space. And the last thing I wrote down was security,
because
Bennu is a potentially hazardous asteroid. We heard about the Great DART mission, which is developing planetary defense technologies. And I said, oh, I got OSRS. If I just buy a couple vowels, I can get OSIRIS. So spectroscopy became spectral interpretation, resources became resource identification. And then as the mission grew and got bigger, I decided we needed something stronger than just OSIRIS. And somebody, almost as a joke, said OSIRIS-Rex, and we all laughed. And then I went home that night and I was like, that sounds really cool. And so I was like, we gotta be OSIRIS-Rex. And I came up with my backronym, which is the Regolith Explorer. Regolith is what we call the loose material on the surface of these airless bodies. And OSIRIS-Rex was born.
You know what? I'm totally okay. He's like, OSIRIS-Rex doesn't really fit the acronym, but frick it, it sounds cool. Totally okay with that. Yeah, no, we're good. Yeah, yeah, of course. It's like, you know, it's like Elon with Cybertruck. You're like, why did you make it bulletproof? Because it's cool. Because it's badass. All right. Yeah. Okay. Yeah. Yeah. No. I'm just please keep doing that.
All right. Let's go to our next media question.
Good morning, Sophie Sanchez with Cosmic Chicago. Dante, I want to thank you for demonstrating right now how important it is to have an imagination and use it in scientific investigations. Based on that, y'all mentioned that analysis isn't limited by the questions asked at the mission conception. Are there any significant tech or methods changes that have already happened or new questions that you guys are already asking? And then if I could ask each of you to use your imagination and share with us any tech or methods that you would love to see in the future as we continue to explore space. Thank you.
Okay, I'll start with that. Yeah, absolutely. Our sample analysis plan is going to be changing and modifying in the future, especially as we make new discoveries and then ask new questions. I mentioned the building blocks of life, you know, amino acids that make up proteins, but what I'm really interested in is, you know, how far did that chemistry go on the asteroid? How much closer to life did it get? So looking, instead of individual amino acids, looking for peptides, maybe chains of amino acids. And we now have the analytical tools that actually we didn't really have when this mission was proposed to actually make those sensitive measurements of peptides. So that's personally something that I'm excited about doing when these samples get to Goddard. We'll be making, we call it Bennu T, and extracting these compounds and looking for these peptides as well. So stay tuned for that.
Word.
So
I don't know.
I'll use my imagination.
I don't know what peptides are.
Which is what I love to do.
Sorry.
So when I think of Bennu, you know, a lot of people that I meet just in everyday life, they're like, why are you so interested in rocks, right? Like, what is so cool about them? Like, because rocks tell you a story, right? And it's the story of Bennu and the history of the solar system that I'm most excited to unravel with the science program. And when we look at the materials, these clay minerals,
that's kind of
carbonates,
important,
you had a lot of water moving around in the early solar system beyond what we really expected from our meteorite investigations. You know, when we look at meteorites, we think water moving in very tiny scales, but I imagine a world right at the beginning of the solar system, right in that protoplanetary disk, where you had a lot of ice and a lot of rock and metal and carbon, and radioactivity started heating these things up, and you got massive circulation, what we call a convecting ball of mud, hundreds of miles across, right? And it's in that environment that I imagine these carbon atoms going through the first stages to the origin of life. And to me, that's the greatest mystery that we're facing right now, is like, how do you go from a ball of mud to something that's alive? Like, what happens when you make that transition? And the deepest, you know, desire is that we're gonna make some progress in trying to figure out, what is it? Why is it that we're here, we're alive, we're conscious in this universe? It's such a gift that I hope everybody really stops and thinks about it every once in a while, no matter what your problems are in everyday life. The fact that you're alive and that you're aware on this beautiful planet is something you should be grateful for every day. And that's really where I hope my imagination takes everybody.
Very, very based. Good answer.
All right,
I like
go
that
to
guy.
another student
That guy's
question,
cool.
please.
How can these OSIRIS-Rex samples help scientists in the future?
So I'll take that one. So one of the great things about curating samples and keeping them as pristine as the day that they're returned is that people, maybe yourself one day, maybe any of the students of this audience, maybe people who aren't even born yet,
Every day,
are going to have the opportunity to use their imagination and the technologies of their time to answer questions that we just can't answer right now with these samples. It's one of the best gifts of sample return.
I'll piggyback onto that.
Bill time!
And tell you that, you know, we brought samples back from the moon over a half century ago. I have just seen at a university where samples have been distributed to that university from each of 4 Apollo landings. And indeed, they are growing plants
There were
in the
6
lunar
Apollo
regolith.
landings.
So who knows what we're going to be doing with these samples as we continue to learn in the future from this asteroid.
And can I just also build a little bit on what has both just been said here? You know, Administrator Nelson mentioned these Apollo samples that were collected, you know, over half a century ago. We actually just opened up one of those samples that had been held in a pristine state that entire time. And just a couple years ago, we opened that sample. We were able to open it and offer it up to scientists around the world to look at that weren't around during the Apollo days. And they have new ideas about what the nature of the moon is. At the time those samples were collected, we thought the moon was a dry and desolate place. And now we know that there's actually water contained in some of those minerals and that there's perhaps even water beneath some of the rocks in the permanently shadowed craters. And so being able to have a new generation of scientists using the state-of-the-art instruments of today to examine those samples with new questions that people didn't even know were going to be questions at the time they were collected really demonstrates, I think, in a really real way, just exactly what we're going to see with the OSIRIS-Rex samples decades into the future.
Thank you.
Yeah, I mean, wait, Chris, you asked if Bill's doing a good job. Yeah, I'll be 100% honest with you, and, you know, people probably don't really want to hear this, but honestly, so the guy that was before Bill, the NASA administrator, it's Bill Nelson. Bill Nelson was a senator from Florida for a really long time. He lost the midterm election in 2018. I forget who he lost to. I don't really care. Not my state. So, the guy that came before him was a guy by the name of Jim Bridenstine. Jim Bridenstine was, I think he was a representative in the House of Representatives from Oklahoma before he was a NASA administrator. And the reason why I bring up these points is because, you know, Jim did a good job. He worked for the guy that was in the White House before the current guy, right? But he did a good job. And Bill works for the guy that's in the White House right now. Bill also did a good job. He's also doing a good job. NASA didn't really change much, believe it or not. You know, the goals didn't really change at all. NASA basically has been running the same course that since basically 2018. Nothing really changed. I was worried about it. It was something that kept me up at night for a little while. Not because I was worried that Bill wouldn't do a good job. It's just, you know, historically with Constellation going out the window, when you get an executive branch change like that, you know, stuff gets thrown up in the air. But actually, it all landed right where it was. Right where it landed, right back where it came back down, right where it was. Stuff's pretty much the same. In fact, Bill has been able to build off of what Jim did, believe it or not. Fun fact, and this is the reason why I mentioned that Bill lost election in 2018. The second he lost election in 2018, Jim Bridenstine, the current administrator of NASA at the time, went right to him and said, "You come on to the National Spaceflight Advisory Council right now." And he was like, "Well, all right, I will do that. I will do that right now." And he went and worked with Jim. So making him the administrator of NASA was actually a pretty damn good move because he was already familiar with what NASA was doing at the time. So, yeah, I mean, NASA really hasn't the goals for NASA hasn't changed in a really long time, and that's a good thing. That's really good. That's what we want. We don't want stuff to change. Just keep running the course, because these missions take time, and they often span multiple presidential administrations. Even the Apollo program spanned technically 3 presidential administrations, if, you count my my guy's term there as a, presidential administration. And then the guy that replaced him, who was okay. So, NASA pretty much hasn't changed. Bill's done a great job, and he's been able to leapfrog off of the foundation that Jim built him. And simultaneously, Jim Bridenstine was able to leapfrog off of the foundation that Charlie Bolden before him did built up. NASA's goals have not really changed that much. Even in 2018, when they, retooled, things, they changed some stuff around in 2018, like establishing the Space Force and stuff, which I still think is a good idea to this day. The goals really haven't changed much. They're pretty much the same. Wade Crush, Bill has done a pretty damn good job. I mean, I do rib him. I do give him crap because he has an amazing old school Florida accent. Like, he is old school when it comes to this stuff. No, he's good. He does give political answers from time to time and non-answers from time to time, but it's something. The point that I'm trying to make, dude, is that Bill's a politician. So is Jim. And you know what? As weird as this is going to sound, I don't want a scientist running NASA. That's a really bad idea. I don't want an astronaut running NASA either. Also a bad idea. A politician is the guy to run NASA. You need somebody that can speak both languages. Jim was in the House of Representatives in Oklahoma. He knows politics. He's good at it. Bill has way more experience in politics than Jim did. Bill has 30 years of politics. He was a senator from Florida for a really long time. That's great. He's plenty of experience. He knows what levers to pull, and he knows what buttons to push, right? And having the NASA administrator having political competency is what NASA needs. I don't want a politician running NASA's Science Mission Directorate, for instance. That's a bad idea. Don't want that. We need scientists running the Science Mission Directorate. You need engineers running the Human Spaceflight Operations Directorate. That's where you put your scientists and engineers. You don't have a scientist run NASA. That's a really bad idea. Or an engineer, for that matter. Not a good idea. Now, if they're a politician and an engineer, yeah, sure, great. Good. That's fantastic. But having someone that has the political competency and the political capital to be able to throw their weight around is good for NASA. And Bill has a lot of political weight. Fun fact, Bill's also been to space. He flew on the space shuttle in 1986. The flight before Challenger, believe it or not. Yep, he's been to space. I would like to add, just as a kind of additional thing to this, that Bill runs NASA. He has one right-hand man and one right-hand woman, I guess. So the deputy NASA administrator is a woman by the name of Pam Melroy. Pam Melroy has also been to space. She was a shuttle commander. She flew the shuttle multiple times. And then the third guy in charge, the deputy associate administrator, I think is what it's called, is a guy by the name of Bob Cabana. Bob Cabana flew the shuttle as well 4 times. Yeah, and he's also a U.S. Marine, which is pretty cool. I mean, fun fact, Charlie Bolden, the guy that Jim Bridenstine replaces, also a Marine that also flew the shuttle multiple times. Even crazier fun fact, that shuttle flight, SDS-62A, that flew in mid-January 1986, once again, it was the flight before Challenger, had 2 NASA administrators on it. Bill Nelson was on it as a passenger. Charlie Bolden was flying the mother. Oh, yeah. Pretty cool, huh? The top 3 people at NASA have been to space. That's really cool. I thought that was a really awesome statistic. Yeah, I've actually talked to Pam before. She's really, really cool. Yeah, I've talked to her about flying the shuttle. She's about flying the shuttle. I had the pleasure of meeting her at Intrepid one time. Yeah, she's cool. She knows about space. Yeah, I've never met Bob Cabana before, but I mean, U.S. Marine, flew the shuttle 4 times. Yeah, he's cool. He's cool too. Yeah. So yeah, Weight Crush. Bill's been doing a good job. He's been doing a good job. Like I couldn't ask for a better combination here. The top three at NASA have all been to space. The guy that runs NASA is very politically competent, and scientists are running the scientific divisions of NASA. It's how it should be. This is how it should be. Please keep doing this. 61C, excuse me, not 61C. Yes, 60. Yeah, thank you, Thomas. It was 61C. 62A was different. It was a different mission. But anyway, I think that's it's really cool. Yeah, Bill's been doing just fine. Yeah, he's been doing just fine. And I'd like to add that, you know, Jim Bridenstine, the guy that came before Bill, and Bill don't really see eye to eye on many things from a political standpoint. But that doesn't matter because NASA supersedes that, and that makes me really happy. It's nice to have a breath of fresh air like that. Granted the circumstances, you know what I mean? It's really cool. Anyway, let's finish this up. 62A was Slick 6.
All
Thank
right,
you.
We'll go to the media.
Allison McGrath, NASA Social, Texas A&M University. I was wondering if one of the meteorite people could comment how rare or common that magnetite framboid mineral is.
Cool.
In our meteorite collection.
Sure. Hi, Allison. Good to see you.
Yeah.
The magnetite that we're seeing in these structures, the framboids and the plaquettes, that is characteristic of a type of meteorite we call type 1, which is the most hydrated, the most volatile rich, a very important kind of material because it's close in composition to the photosphere of the sun, which means it probably represents the bulk composition of the protoplanetary disk, the material that everything was formed out of. And then fractionation took place as different high temperature minerals formed, or you had melting occur. So it does look really like something that would precipitate out of liquid water. And that is one of our clues, along with the water-bearing clay minerals and the carbonate minerals, that we are dealing with a very wet environment early in the solar system. And of course, there's a lot of work to go to dig into those minerals and get the details and the story to pull out the history that's locked inside those grains.
Thank you. All right, we're going to our final 2 questions, one from the student and one from media. We'll take our student question right now.
Hi, my name is Donald Jernigan. I am a 7th grader from DD Middle School, and my question is, how will OSIRIS-Rex help us prevent future asteroids from impacting the Earth?
That's an excellent question, and I'm going to take a stab at this, although Dante's going to jump in and correct me. But one of the things that we were able to do with the OSIRIS-Rex mission when the spacecraft was there orbiting the asteroid itself was measure a very, very small force that acts on the asteroids. So we know that gravity is going to determine kind of the large orbital parameters and help us predict where the asteroids are going to go. But it turns out that when the sun is heating up one side of the asteroid and then the asteroid turns and rotates and that heat is radiated out into the dark space, that also puts a little tiny force on the asteroid. And that particular effect, it's called Yarkovsky effect. You can impress your friends with that later if you like. But knowing what that little tiny force is and how that operates over a very, very long period of time is really important for helping us be able to predict when a particular asteroid might be dangerous. What we really want to know is if an asteroid is going to cross over Earth's orbit at the same time that we're in that place. And we want to not be in that place when the asteroid comes by.
That's
so
cool.
Being able to precisely predict that is really important. So Dante, you want to
No, that
add
was
to that?
great. I do want to add, I think one of the most important things from OSIRIS-Rex is the amazing flight dynamics team and the precision with which they were able to design the maneuvers around Bennu. It's unprecedented in spaceflight, and I don't think that gets out enough. But just the technology to rendezvous with an asteroid like this, and to get the spacecraft into precise locations to get the exact data that we needed for our site selection and to unravel the geologic history of the asteroid is amazing. And by the way, we have 2 Guinness World Records celebrating those accomplishments. So just that knowledge alone is going to be essential for humanity as we go out to deal with one of these objects that might be on a collision course with the Earth. So I do want a round of applause for the Flight Dynamics team, by the way. They're my heroes, for sure.
Fido.
All right, and now we'll take our final question from media.
Hi, everyone. My name is Alyssa Luongo. I'm with NASA Social, and I'm here representing Space Foundation. So us media professionals have been using hashtag to Bennu and back, and I'm wondering if there's going to be a hashtag back to Bennu, or if you guys are moving on to other asteroids.
I'll take that one. So we find asteroids in a lot of diverse parts of our solar system, and each of those different populations can tell us different things. While it may be interesting to go back to Bennu, I think my expectation is we're going to keep sampling different parts of that story, different types of asteroids that can tell us different things about that origin story. Dante was talking about what that was like in the earliest times, but each one of those different asteroid populations can tell us something different. And there's a whole host of asteroid types that we haven't visited yet, so we really want to make sure we complete our sample.
And just a quick follow-up on that. I actually hope we don't have to go back to Bennu, because it means it probably is on a collision course, right? We have to deflect it. So just to clarify.
And to note, it's not. In the next over 100 years, well over 100 years, before it even is potentially close. So don't worry.
Sorry, there was a fly.
So
I got it,
now
for what
that
it's worth.
we've had this discussion, and you all were excellent, and thank you for explaining it so well, I want to particularly say to the students here, it wasn't too long ago, a decade ago, that people were actually belittling the fact that we would go to an asteroid, or the thought of capturing an asteroid and bring it closer where we might examine it. There are always going to be naysayers. Just think what Copernicus and Galileo faced when they dared to think that something was new and different and wanted to explore. So the message for you students is you're in the golden age of space exploration. Don't let anybody deter you. Keep on it.
Little bit of community notes on that. The asteroid redirect mission was proposed about a decade ago. It was proposed instead of going back to the moon first. That's why there were naysayers. Also, it was proposed with no rocket. Just thought I'd put it out there. Yeah, that's why there were naysayers to that. Because they were proposed an asteroid redirect with a rocket system that didn't exist and capsule that was in very early development. They proposed an asteroid redirect on SLS Block 1, which, no. Proposing an asteroid redirect with SLS Block 1 would be like saying, I want to build a space station with Electron. Now, it's not that Electron is a bad rocket. It's not that SLS Block 1 is a bad rocket, but not the right tool for the job. That's why there were naysayers to that. Because the rocket that SLS replaced was more than capable of doing something like that. But we didn't want that because we thought going to the moon would be too expensive. There's your, yeah, interesting context, right? It's interesting that he would bring that up. Well, Drummer, the way it's interesting because the way that he phrased that kind of seemed like, without context, it's like, oh, frick the haters. But the point that I'm trying to illustrate is that it's a little bit more complicated than that. To be fair, there was also naysayers that think, that all spaceflight endeavors are worthless. So are we being fair to the people that say space is a waste of time, Uncle X? I'll be 100% honest with you. I don't want to be fair to those people. Frick those people. Yeah, frick those people. I'm not being fair to any... No, screw them. That's why it's important to add context, because that's how it's phrased. No. That is not how that went down. And $30 billion. Nope. I'm not going to stop talking about it. Sorry. No, you're being fair to Pudding Man. No. 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 Anyway, back to this.
All right. Thank you all for your questions. This now concludes our OSIRIS-REx sample reveal event. We appreciate your attendance and devotion to this one-of-a-kind mission. Please remember there's a lot more to come and to see from OSIRIS-REx. For more on the mission and to stay up to date, the latest findings, please visit www.nasa.gov/OSIRIS-REx or scan the QR code on the screen. Over the next 2 years, from late 2023 to 2025, the science team will characterize the samples and conduct the analysis needed to meet the mission's science goals. NASA will preserve at least 70% of the sample at Johnson Space Center for further research by scientists worldwide, including future generations. With these findings, NASA can take another giant leap forward for the agency and for humanity. Thank you all for joining us today. That concludes our program.
Cool. That was awesome. Very, very, very cool. So, people have been posting links in chat. You want to watch... What's the next thing here? The Psyche mission. What is this, Zero? OSIRIS-REx sample reveal media teleconference.
Go on your TV or computer and listen only to audio from the phone.
Oh.
Or 1 to be added to the queue.
Sweet.
If you'd like to withdraw your question,
Let's
press
keep
star
going.
2. Do not use your speakerphone when you are asking your question. Again, today's conference will begin shortly.
The NASA audio actually being at an audible volume, Friendship? Never mind. Spoke too soon. Spoke too soon. Yep. What would you think about Mark Kelly becoming a NASA administrator in the future? Yeah, I'd be okay with that. Spoke to a spoon. Hey, spoon you, alright? Fork off. Does supersonic retropropulsion work in KSP? Yeah, but not for the same reasons, Twisted. But yeah, it'll work. The way stock Kerbal's atmosphere is kind of set up, you don't really need... let me just put it to you like this. Re-entry heating in KSP is very, very, very understated. Yeah, very understated. Yes, Alex, this is... yeah. I actually know it's a Cisco WebEx codec because they've played the Cisco hold music on here before.
Hello and welcome to today's Media Telecon. Today we are discussing the initial findings of NASA's OSIRIS-Rex asteroid sample after its reveal earlier today. I'm Shaniqua Vereen with NASA's Office of Communications. In the room with me, I have a panel of experts that will answer questions for you today. With me is Nikki Fox, NASA's Associate Administrator for NASA's Science Mission Directorate. I have Jason Dworkin, OSIRIS-Rex Project Scientist from NASA's Goddard Space Flight Center. Professor Dante Loretta, OSIRIS-Rex's Principal Investigator from the University of Arizona. And Dr. Francis McCubbin, Astro Materials Curator from NASA's Johnson Space Center. We'll begin with some opening words from Dante Loretta, the Principal Investigator, and then we'll open up for questions for media on the line.
Thank you, Shaniqua. It's great to be here at NASA's Johnson Space Center, where since September 25th, when the OSIRIS-Rex samples arrived on center, we have been systematically and methodically getting into the science canister and ultimately to the sample collection device, which we call TAGSAM, the touch-and-go sample acquisition mechanism, the actual piece of spacecraft hardware that touched the surface of asteroid Bennu and collected material back in 2020. It's been a very exciting set of weeks. When we first opened the science canister, we saw that there was abundant fine-grained black asteroid dust, as well as larger particles of about a millimeter or so, roughly a 1/16 of an inch across. We did collect some of that material for distribution to our sample analysis team. We had a group here, the Quick Look team, which took it to the electron microscopes and optical instruments, as well as shipping some of it to the Carnegie Institute in Washington and NASA's Goddard Space Flight Center for initial assessment. And we're already thrilled with the results. We have verified that Bennu is dominated by water-bearing clay minerals. We have found iron minerals in the form of iron sulfides and iron oxides, which themselves are indicative of formation in a water-rich environment. And perhaps most exciting, the sample contains about 4.7% by weight carbon, which is obviously the essential element for all life on Earth and central to our astrobiology investigations. We did remove the TAGSAM device from its capture ring. You can kind of think of this like a boot clicking into a ski. So we had to remove the cams and lift it off. When we did so, some material slipped out from the mylar flap, which is kind of the check valve designed to hold the material inside the sample collector. And we got some amazing shots of the diversity of particles that are visible right now. Over the next couple weeks, the curation team will continue to disassemble the TAGSAM. There's a series of steps that we need to go through before we can actually get into the interior, but we're optimistic that we'll have a pretty good estimate of the entire mass of the sample within 2 weeks or so. So it was a really great set of presentations we gave today, and I believe we're here to allow media from all over the world to ask any follow-on questions.
Thank you, Dante. And if you are media on the line, to get on the queue, press *1 to be put into the queue for online questions. I think we do have our first question up for the group, and that is from Marcia Dunn with AP.
Oh, yes. Yes, Dante, I was going to ask you when you plan to open up your container, and you said in 2 weeks. That's great. I saw some of the big rocks, the troublesome ones. Could you say, can you hear me here? I'm sorry.
Yeah.
Oh, okay. Yeah, I was. Thank you for answering how many weeks before we get some clarity on how much you brought back. 2 weeks. But the rocks that we saw, the troublesome ones especially, look pretty big. How big were those? And based on the size of those bigger rocks, what's your best guess of how many grams you have based on what you can see?
They couldn't close the canister, Blackbird.
Well, that's a tricky question, Marcia. So I can definitely tell you about the size of the rocks that we're seeing right now, and maybe Francis will want to weigh in here in terms of the challenges in estimating mass. But yeah, we see some of the troublemakers. There's still rocks that are wedged between the bottom of TAGSAM and the mylar flap, and as we know, in 2020 we saw particles escaping TAGSAM as a result. Some of those are 1 centimeter or 2 centimeters in their longest dimensions. And when I look at the entire exposed material, I'm seeing of order a dozen stones at that centimeter or larger scale. But Francis
inch.
McCubbin's here. He's our astromaterials curator at Johnson Space Center. Maybe you want to talk about the challenges of trying to come up with a mass based on what we know right now.
Right. So the biggest challenge, so we have containerized about close to 1.5 grams of material off of the avionics deck. And as we were measuring those particles, particularly the intermediate-sized particles, some of the larger ones weighed less than we would expect, and some of the smaller ones weighed more than we would expect. And so there's obviously some variations in density for this sample. But what we can say is we're very excited about the volume of material that we have.
Thank you. Thank you, Marcia. Our next question will come from Alexandra White with Nature magazine.
Hi, yeah, thanks much for holding the follow-up call. I wanted to ask about this 4.7% carbon. How does that compare to other meteorites? There was a mention, I think, of that perhaps being the most highest carbon percentage in extraterrestrial samples. Just walk me through a little bit about kind of what other carbon-rich asteroids contain in terms of percent carbon and how Bennu compares with this 4.7% number, please.
These are good questions.
Hi, this is Jason Dworkin, project scientist, NASA Goddard. The 4.7 is on the high end for carbonaceous materials, for meteorites and carbonaceous asteroid sample return, of which there's been one other. It's within the range of what was seen on Hayabusa 2, and this is, again, very, very early results from one set of samples that was collected in the quick look exercise. So there will be a lot more to discover as we explore. But in the range of meteorites that have been studied, this is among the highest. It's in the top tier. It's what we were exactly hoping for, and we are delighted to be able to explore that over the next 2 years and, of course, over the next decades.
Thank you. Our next question is going to come from Kenneth Chang with the New York Times.
Hi, thank you. I have a question. What is the definition of organic carbon in this context? And how do you differentiate that from non-organic carbon?
So we have a working definition of organic carbon, which would include carbon-containing molecules that you could have graphitic material. We'll call that organic. Now, of course, remember that we haven't done analyses of things on these edge cases yet. That'll happen. So to get overly detailed, we would consider, say, Buckminster fullerene, which is pure carbon, could still be considered organic. We would not consider something like a carbon steel to be an organic molecule, even though it has carbon. Typically, organic is defined as carbon plus hydrogen, but we have some other cases of organic compounds that would be edge cases for those. But in general, for general audience, carbon molecules that have carbon, hydrogen, and other atoms.
And they're definitely not in a crystal. With something with a unit cell, with a repeating structure like a carbonate mineral, we would not consider organic. So the molecules are soluble. Some of them can be extracted with water or acids, and some of them are insoluble, but they look like kind of macromolecules, very large in structure.
Full-like.
Yeah.
And you, of course, can form crystals of organic compounds like the sugar in your sugar bowl, but that's not the sort of thing that we're discussing here.
Right.
All righty, thank you. The next question is going to come from Leo Enright with Irish TV.
Who still has a sugar bowl?
Yeah, thanks very much for
Leo.
doing this extraordinary material. I was a bit curious about the clay. You've confirmed, obviously, I mean, you saw it spectroscopically at the asteroid, but you're now confirming clay minerals. And you were talking, Dante, during the Houston briefing about a catalytic element in the metals that you're seeing, all of which really speaks to extraordinarily strongly to the idea of formation of organic compounds and more complex molecules. Could you talk about how this all might fit together?
Sure. So of all the minerals that I introduced, we've got the clay minerals, we've got the iron sulfides and the iron oxides. All of them have been investigated in various prebiotic studies as potential catalysts for important molecules that may then go on to be incorporated into biology at some point. We're interested in the origin of homochirality, which is the property of amino acids to have a left-handed version and a right-handed version, and life preferentially uses the left-handed version. The sugars are opposite. The ribose in RNA, for example, dominantly as a right-handed version. And so when you produce these things through an inorganic chemical reaction, you tend to get both hands in equal abundances. But there are certain properties of these mineral surfaces. I know the iron oxide magnetite has been looked at in this manner, where it might preferentially absorb one-handed molecule over another based on defects in the crystal structure, and that might be a natural way to concentrate one version of the organic molecule over the other. There's also just catalytic properties where we may be able to produce molecules that wouldn't otherwise form rapidly without the mineral surface to speed up the rate of the reaction. And maybe Jason, do you want to add anything to that?
It's a wide range of things that can be considered. The prebiotic chemistry has decades of studies on what could be plausible, and it'll be very exciting to be able to look at the chemical networks that we'll be able to piece together from Bennu, looking at the organic compounds in the interaction with the inorganic and the compounds in the mineral species, to try and push those frontiers forward and look at some old hypotheses to see if they may have played a role on Bennu's parent body.
I had a follow-up, if that's possible.
Yep, go ahead.
Oh, thanks. Yeah, I was curious also about the water content of these samples. Are you expecting to see H2O? And if so, we heard again at the Houston briefing earlier about, we know that, water may have come to the Earth from objects like this. But I do recall that the Europeans were surprised to find that the D to H ratio at the comets was not consistent with that. Is it possible for you to progress this discussion?
Yes, absolutely. So we will be looking for water, and really to be specific, it's the hydroxyl ion, the OH ion, which gets incorporated into the crystal structure of the clay minerals. You can have interstitial water molecules in between the layers of the clays as well, and we'll be looking for both of those forms of water. And we will absolutely be measuring the deuterium to hydrogen ratio of the minerals and any other phases. One of the things we're excited to look for are fluid inclusions. The carbonates and the sulfides in particular, if they formed by precipitation in a hydrothermal system, they may actually have trapped some of the water, now kind of like locked inside a little cell inside the mineral itself. And so we might actually have samples of the asteroidal water directly. That's still a hope. We need to do the work, but it's not out of the realm of possibility. So yeah, all of these questions, the isotope ratios, the form of water, where it is in the crystal structure, and unraveling the formation pathway is part of our sample analysis plan.
And following that deuterium to hydrogen ratio from the water into the organic compounds that were synthesized in that water, to understand how that plays a role, or which compounds came from where in that process.
Thank you. And again, if you are a member of the media on the telecom line, please press *1 to be put into the queue. All right.
Yeah, I got the news.
All right, I see another question in the queue. We have a question coming in from Marcia Dunn with AP.
Yes, I know you don't like guessing, but I'd really wondering, what's the minimum amount of samples that you would guess that you brought back? Are you
I would say the
comfortable
minimum is
saying
1.5 grams because that's what we've measured.
5 grams? Well, do you think you've achieved the minimum 60 grams at least based on what you've seen, even though you've not measured it?
I don't think we can answer that, Marcia. We want to make the measurement.
Okay.
Okay. That was a no.
Next question
Go away.
is from Alexandra Whitby from Nature Magazine.
I love it when that's
Hi again.
that.
I wanted to ask
No,
about
go away.
carbonate. Have you seen carbonate? If so, where and how much is there?
Yes, we have seen carbonate. Some of it was visible in the UV fluorescence image that Danny Glavin showed at the auditorium event here in Houston. We are seeing calcite, which is the calcium-bearing carbonate. We're seeing magnesite, which is the magnesium-bearing one, and brunerite, which has magnesium, iron, and manganese in it. So we're seeing several different species of carbonate. It's very early days, as you know, Alex. We want to make sure this is all based on elemental abundances. We haven't done any structural work. So I probably should walk back the calcite in the sense it could be a polymorph called aragonite. So we will be doing all kinds of crystallographic characterization, transmission electron microscopy, X-ray diffraction.
Some of them.
But we do see a wide range of carbonates, similar to what we predicted from the spectral analysis of the surface of Bennu from the OSIRIS data.
And can I just follow up with a completely innocuous question after that? Dante, do you have a favorite rock or grain of dust that you've seen so far?
I do, but it's love at first sight right now. So it's looking at those amazing images from Erica Blumenfeld and her team, which is doing the fantastic photo documentation. And I spent all weekend staring at those images, and I do have a favorite grain. I've already told Francis about it. It looks fragile, friable, so it's delicate possibly, and it reminds me of the dark black hummocky material. It was, I believe, in my panel D on my graphic is the one that I'm currently enamored with. But of course, you know, you can't have a favorite child, so all of them look amazing, but that one I really want to understand what's going on.
Thanks.
Yep.
Thank you. Next question in the queue is from Leo Enright, Irish TV.
Yeah, thanks. Sorry, I'm not trying to dominate the meeting, but if there's nobody else asking questions, I realize you don't have anybody from the Colorado School of Mining, but this is kind of that sort of a question for on behalf maybe of the children's children who will be going out to these asteroids. You were at a C group asteroid. Obviously, there's this extraordinary Psyche mission about to go out to an M-type asteroid. Could somebody maybe talk us through, if you were a miner, what of each of these asteroid groups that we visited would be exciting about each one? I'm assuming you would be looking, in your case, more at water than anything else, but I simply don't know.
I'll take a shot at that. I've worked with some asteroid mining startups, and they've all gone bankrupt. So it's a tough business, a tough way to make a living. The problems are it's a huge infrastructure investment and a very long timeline at a high risk if you're ever going to see any kind of economic return on the prospect. But of all the cases that we looked at, the one that was the most compelling was, as you mentioned, mining the water, processing that water into liquid hydrogen and liquid oxygen, and using that to refuel spacecraft to go deeper into the solar system. You know, when we launched OSIRIS-Rex, it was 2,100 kilograms of mass, 1,200 kilograms was fuel. So you can imagine a much less capable launch vehicle if you could refuel in orbit. But, and so Bennu would be great for that. We still don't have a number on the 8% water. That's a measurement that's coming. Yugu would also be a good target because it does appear to be very rich in water as well, and then easy to transport, and you could do the dissociation into liquid hydrogen, liquid oxygen down the road. So the sci-fi geek in me can't wait to see this happen. The practical scientist realizes we got a lot of work to do before this is really even credible.
Let me jump in as well.
Sure.
I'll also point out that we actually had a number of members of our engineering team who are graduates of the Colorado School of Mines. So with respect to them. But when you have an enterprise like this, you need to know what your customer is. And the customer will dictate what it is you need. So if there's a need for, I don't know, a catalytic material for spacecraft in situ, then that's what you'll mine. If it's need for fuel, that's what you'll mine. So find the customer first and then develop your business plan.
Good advice.
All right, and I think we have Nikki Fox who wants to follow up on this.
That was a really good question.
Yeah, thanks. I was just going to sort of remind everybody that NASA does not do missions to mine asteroids. We go to study them, to learn about them, and to just gaze in wonder at them and open the treasure trove of discoveries that our asteroid missions discover. And so I was super excited about the samples coming back and being able to look at those, and also getting ready to go Psyche tomorrow.
Hear, hear.
All right, the next question in the queue is from Kenneth Chang with the New York Times.
Hi, thanks for taking another question. I was wondering if you could compare what you saw in the quick look research versus what you had seen in the remote measurements when you were at Bennu. Did you see hydrated clays then? And I guess what sort of confirms what you saw previously and what was actually new? Thanks.
Yeah, thanks, Kenneth. So the predictions were very specific. We thought we would see from both two instruments, the OSIRIS instrument, which is the visible and infrared spectrometer, and the OTIS instrument, which is the thermal emission spectrometer. We did see strong indication of hydrated clay minerals, both in the 2.7 micron region in OSIRIS data and the 10 micron region in OTIS data. We did see magnetite, which is the iron oxide. We did see carbonates, including multiple variations, calcite, magnesite, dolomite, brunerite were all predicted.
It's
We're starting
dolomite,
to see
baby!
that diversity in the carbonate mineralogy right now. And of course, abundant organics all across the surface of the asteroid, which initial analyses support that as well. The species we didn't see that I reported on today were the iron sulfides, and that's because they're not spectrally active. So I had postulated that they would be there just based on knowledge of solar system chemistry, and in fact they were there. So pretty much we predicted the mineralogy very accurately, and we also predicted a very low abundance of anhydrous silicates, things like olivines and pyroxenes, which for example make up the mantle of the Earth and a lot of the stony type of asteroids and meteorites. And we have maybe found a couple small grains of those, but they're very minor components, again, consistent with our spectral analysis.
All right.
And maybe I should mention for Kenneth, if you're really interested in the details, I did post the entire sample analysis plan on archive.org for anybody to download and review in detail. Just caveat emptor, it's about 270 pages long.
Our next question is coming from Colin Baker with Al Jazeera English.
Hi, thanks for taking my question. So with Hayabusa and with Stardust, the public perception at the end was all about amino acids, and I just want to know, and forgive me if you've already explained this, what's the viable path from where you are right now to learning about some of those much more complex forms of carbon? How long do we have to wait? How many steps do you have to go through to get there? What are you expecting to find?
So I can take part of that. Is we have a detailed sample analysis plan that you can also look at on archive, studying the organic materials from the volatiles all the way up through the large compounds, the pHs, the insoluble organics, with an emphasis, of course, on soluble compounds relevant to astrobiology, to life, amino acids, small peptides, sugars, all these sorts of compounds. Once the samples have been decided upon and allocated to the team, then the worldwide organic sample analysis team will get to work and have those results soon. And I'll let Francis tell us when that might be happening, but we have to do whatever's best for the sample.
Yep. So we anticipate getting more sample out to the science team within the next month or so. And the general scientific community will have a shot at these samples when the sample catalog comes out in about 6 months from now.
Next question is from Linda Shiner, Smithsonian Magazine.
Hi, I have a question about sample distribution. You mentioned that some of the sample from outside the TAG SAM was already sent to Goddard and to Carnegie. What was the purpose of that distribution, and what type of analysis was done?
Yeah, so part of the plan was always that there was going to be this quick look analysis with any material that might be on the avionics deck and outside the TAG SAM. We actually had even more than we were anticipating, and so we sent 138 milligrams out to that team so that they could do those preliminary analyses We've containerized about 1.5 grams of material so far just from the avionics deck. And the material we saw today on top of the Mylar flap, we haven't even measured the mass of that material left. So we've got a bounty of material here. And I'll let Dante tell you a little bit about what they were able to do with that 138 milligrams.
Right, thank you, Francis. So I mentioned when Kenneth Chang had the question, we had these predictions about the nature of the sample based on the remote sensing campaign at Asteroid Bennu, and we wrote a 270-page sample analysis plan based on those assumptions. So the very first thing I wanted to know was my sample analysis plan still valid, or did I have to scrap the whole thing and start from scratch because Bennu surprised us once again? So the good news coming out of this is we're pretty much seeing what we expected. In some cases, we're surprised, but in a very good way, the high abundance of carbon being, I think, the prime example of that very wonderful surprise. So I can rest easy that we will continue to work through the sample analysis plan as envisioned. It is a hypothesis-driven plan, and the hypothesis number one is testing the prediction of the mineralogy and the abundances and the relationship to known meteorites. And so I feel good that we're going to be able to continue down that path. Of course, we did collect a biased sample. The stuff that was outside of TAGSAM was very fine-grained, probably why it got out. And there's much more coarse particles and large particles on top of the Mylar flap and inside TAGSAM, and we don't know what they're going to be like. But part of our plan is to assess the diversity of material, and any new kind of rock that we see, there is a plan to go ahead and do basic characterization and see how that ties into our hypothesis-driven sample analysis plan.
Next question is from Assam Ahmed from AFP.
Hi, yeah, thanks for taking my question. A couple of things, one a bit on the scientific side and one a bit more on the engineering. The first one is, what is sort of the competing theory for how Earth acquired its water and carbon? If the dominant is that it was seeded from asteroids, what is the competing? And the second question was, sorry to harp on about this, but with the TAGSAM, I think Dante mentioned at the top of the call that some of the material slipped out of the Mylar flap. Does that mean that there could be less than the 250 grams which was estimated? And when will we know? I mean, is it possible that most of that material is no longer there? Thank you.
Where's it going to go?
So there are a number of hypotheses.
Is it going to get up and walk away?
Water, depending on the amount of water in the deep mantle of the Earth, how much could have come from initial accretion, to how much water was delivered from extraterrestrial materials such as comets and asteroids and the ratio of those materials. It tells us something about the stratification of water isotopically within the early solar system. So these are hypotheses that we can investigate, and every exomaterial we look at gets us a little closer to understanding this diversity of origins of water and volatiles on the primitive Earth. Let's see, the other one was on the
mass, the TAGSAM leakage. I'll take
right.
that.
Okay.
Yeah, so it's important to recognize that, prior to understanding that material was leaking out of TAGSAM, we had a very elegant physics experiment plan to measure the mass of the return sample. We were going to take TAGSAM and extend it out 90 degrees from its sample collection configuration and kind of twirl it around. We did that when the TAGSAM was empty. We were going to do it again when the TAGSAM was full, but once we saw the leakage, we realized that would just exacerbate the problem, and we'd probably lose more material by trying to make the mass measurement. So the guidance, navigation, and control team at Lockheed Martin came up with this new technique using the momentum transfer between the robotic arm and a component on the spacecraft called reaction wheels, which absorb momentum, basically. And so we have 250 grams, but I want to make sure people understand there's an uncertainty on that of 101 grams. So even within that measurement, if we had 149 grams, it would still be consistent with the estimate, as well as up to 351 grams. So if we're anywhere in that range, then the GNC team did a fantastic job of estimating our mass.
Cool.
And nobody is more anxious than I am to get that mass number, but I'm practicing my patience, and I'm fully respectful of the need to do this carefully, because it's not just about the science program on OSIRIS-Rex, it's about the future integrity of the entire collection. And we're dedicated to making that happen, and we will get that mass number to you soon. So I urge patience as I'm practicing it right now.
Cool.
Thank you. And I'll remind those on the line, if you have a question, please press star 1 to join the queue. Next up, we have a question from Jeff Parrott, who is called in from the Salt Lake Tribune.
Hi, good afternoon. Cheers from Utah. Just a quick question about kind of looking forward to that Apex mission, what you're seeing and what, like, you'll decide on what you've seen in the next few weeks. Will that shape that visual-centric Apex mission? Will it help those OCAMs understand what they're looking at a little better? Kind of like, how does it shape like this follow-on mission in the future?
That's a great question. And yeah, one of the key objectives of OSIRIS-Rex is the spectral interpretation, right? We wanted to understand how well the instruments that are on board the spacecraft did at predicting the composition of the material on the asteroid surface. And by bringing some of that sample here to Johnson Space Center and ultimately distributing it around the Earth, so far we're validating those instruments. They really look like they performed well. Their sensitivity was as we expected, in fact exceeded it by a bit. And so we can then confidently go and take that same suite of instruments with better calibrations because of the return sample and do an even better job characterizing asteroid Apophis, which will be very different. We're expecting it not to have these hydrated clay minerals and these carbonates, but to be stony and metallic material like the most common type of meteorites that land on Earth, what we call the ordinary chondrites. But yeah, this was about ground truthing our astronomical data as well as our spacecraft-based data, and the samples, a lot of our sample analysis plan is focused around understanding how well those instruments are capable of characterizing the surface. So far it looks really good, and that gives us a lot of confidence going into the Apex extended mission.
Thank you.
Thank you. The next question we have is coming in from Matthew Perot with La Presse.
Hi, thank you for taking my question. I know you asked us to be patient, but do you think you'll have a number on the weight of the sample before Christmas?
Absolutely. I'll let Francis answer that one. Yeah, but I hope so. I don't know if I can wait that long.
Yeah, we should have a mass by Christmas for sure. I'm expecting one within the next few weeks.
And so am I.
Yep.
So yes.
Excellent, thanks.
Yeah, and just to add, like, the only reason we don't have one now is because we found a lot more asteroid material on our way in than we were expecting, and that's a great problem to have. And so we're containerizing that material as carefully as we can, documenting everything in the process. And like I said before, we are very excited about the volume of material we see, and we can't wait to convert that volume into a density and provide you with a mass.
Thank you.
Yeah,
Next
but how much
caller
do you
is
think you have?
Colin Baker with Al Jazeera English.
Hi, so I know there's this long-term plan to store some of these samples, or actually quite a large amount of the samples for future generations to study. Is there like a time capsule timeline for how it's opened up over time, how it's stored, when scientists of the next generation are going to have access to it? Do you have like a roadmap for that?
Yes, what we have for every single one of our astromaterials collections is what we call a conservation plan. And this conservation plan gives us a sort of target to aim for how much of the sample to distribute every year as we go forward. And that conservation plan is designed to keep abundant material for this collection for decades and decades. And so there's not going to be any sort of putting stuff away and leaving it there, and that is the specific sample that will not get touched. It's just our overall conservation strategy for how we do astromaterials curation, so that there's always going to be material available. We're always going to be answering questions as they come up, using whatever the technology available is, and we conserve it so that it's there for good.
Thank you. And there are no more questions in the queue. If you do have a question, please press star 1 to join the queue. And if not, I'll go around the room and ask the folks in the room if they have any words or things that maybe they think you guys didn't ask.
So it's really exciting to be here after waiting for 19 years to get a sample from an asteroid to study.
I don't have a question, Aquilus.
Waiting an extra couple weeks for a wait is hard, but knowing that we're doing everything that we can, and that Curation is doing everything that they can to maximize the value of the sample for the future is worth the wait. Taking the time to containerize and secure every little bit of sample that will hold future discoveries is worth the inconvenience right now.
And I'll just say, you know, watching the curators working in the clean lab with their hands on the glove box, it's so impressive. They are so steady. They are so well rehearsed, and this collection is in great hands. I couldn't be more proud of the entire team.
Yeah, I definitely want to second that. It's been an amazing experience to be here at Johnson Space Center. And even though we want to know the mass, every day there's been something new that's been revealed about the nature of the collection, either from continued work on the quick look sample or flipping over TAGSAM and seeing those particles exposed. So we're not bored. We're having a great time, and I treasure these moments, and I know I'm rapidly running out of them, but where the team comes together with a focus like we have right now, and everybody's working towards the same goal. The excitement is palpable. Spirits are high. It's quite a wonderful time to be engaged on this program. And so I'm not begrudging the delicate and painstaking process we're going through. I'm reveling in it. I'm enjoying it. And I know the mission, there's 2 more years left in the sample analysis program after working 20 years on something that doesn't seem like that long of a time. So it's a little bittersweet to think the end game playing out, and also heartening to know that it's just establishing a baseline for future generations that'll build on our knowledge, that'll be smarter than we are with better equipment, hopefully better funding, and do a great job with this material collection well into the future after all of us have moved on.
All right, and I'll toss it over to Nikki Fox. I know she has some closing words she'd like to say.
Oh, hi. Yeah, thanks so much. I just actually want to take a moment to just give a major shout out to this incredible team. You know, there was nothing about OSIRIS-Rex that was easy. You know, they perfect launch, but, you know, they got to Bennu. It was not what they thought it was going to be. It looked so different. They had to come up with really, really creative ways to actually survey the asteroid, to find that perfect place to go down and do that tag maneuver, you know, bring back the samples. It's just been just such a success, but they are just such a wonderful team. And given that the team is kind of splitting, and some are staying with the samples and some are going to Apex, you know, I think this is just a really great moment for us to show them a lot of love for an incredible job. Really, really, really well done. I'm okay to wait another couple of weeks to know how much sample we have. I can't wait to actually come out to Johnson myself and get a chance to see those samples. But just an incredible, incredible job to an amazing team. So on behalf of NASA, thank you, OSIRIS-Rex.
Cool.
Thank you, Nikki.
Thank you. And that concludes today's Media Telecon. Thank you to everyone who dialed in today.
Okay, I think we have pretty much covered that. So, clay, water, iron sulfides, iron oxides on an asteroid. That's a very similar composition to stuff on Earth, but it's an asteroid. It's not on Earth, which is pretty cool. But it is on Earth. Hey, oh, hey, oh, oh. Pretty cool. Good stuff, man. And if we'll keep this asteroid train going with the Psyche launch tomorrow, hopefully. There's a high probability of violation for the Psyche mission tomorrow. So, I want a mug made of asteroid clay. Don't we all? But seriously, though, how much mass did you get? I know you just said you don't know, but seriously, how much? So we could grow potatoes on Bennu. No. Maybe? Yes? They got 350. That's what I would have said. Yeah, about 350. About 350. And because you pushed out, I'm going to say none, just for you. Yeah, right. If you watch Kyrgyzstan on YouTube, he had a video recently with the potential that life on Earth is actually older than the Earth itself and may have started forming just a few 100 million years after the Big Bang, when the universe as a whole was a temperate temperature zone. Yeah, it's possible. What would really blow my mind, Tessa, is if, you know, there are humans on another solar system. Wouldn't that be wild? It would be a real mind frick if they're speaking English. I'd be like, huh. So SG-1 was right? Yeah, right. Pretty cool. Pretty cool. They'd probably use Imperial. That would be truly the best timeline, wouldn't it? It'd truly be the best timeline. All right. Implying the British Empire colonized other star system. Yeah. If faster than light can only happen with the Imperial system of measurement. Now that would blow my... Okay. Yeah, that means they've gone to plaid. They've gone to plaid. All right. Anything else? I know we already watched this, but it's cool. Yeah, Stoke. Stoke got $100 million in Series B funding the other day. They're gonna have a launch vehicle sooner rather than later, which is pretty cool. Also, yeah, a little bit of a subject change, going back more to the engineering side of things. This was actually happening while we were listening to the press conference. I got 2 more bits of space news here. 3 if we want to be real technical. Won't be real, well, not real technical. It's not really technical at all, but... So check this out. The first one was that Relativity Space signed a multi-launch agreement with Intelsat for Terran R, their reusable rocket. Terran R is supposedly fully reusable solution here. It don't look fully reusable in that application. I don't understand the mass question. I know they know the weight of the container, right? And it's in their hands to weigh it. I'm so confused. Citizen, I think... Okay, so your mind's in the right place, but let's ask a question here. So the interesting thing about how NASA conducts science, for such an abstract scientific concept here, the interesting thing is that the actual scientific method for analyzing this stuff is pretty damn straightforward. All right, so let's talk in common sense, because that's actually a pretty interesting question, right? That would be the question to ask instead of, how much mass did you get? We don't know yet. But yeah, seriously, how much mass did you get? That's a good, your mind's in the right spot. That's a good question to ask, right? So, all right, let's think about this for a second. So they don't know how much mass they have. They know how much the TAGSAM weighs, the canister that has all the material in it, right? So, why can't they put it on a scale? So let's think about that. Now, I'm sure someone at NASA has thought, oh, maybe we can put this on a scale. So why wouldn't they have put the whole thing on a damn scale yet? Why wouldn't they? Let's think about it. Okay, so why wouldn't they do that? Disturbing the samples, perhaps? Like, just think about straight logical stuff. What would happen to the materials if you put it on a scale? Well, not much, but you could potentially disturb the samples, right? It's possible. I mean, the window of error seems crazy. Can't they narrow that down? It's quite possible that they have not done. It's just that they haven't done it yet. To be honest, it's quite possible, right? So, disturb it more than the G-forces during atmospheric re-entry? It's possible. I mean, what I'm getting at, dude, is that there is a really logical and probably a really damn good solution why they haven't just put the stupid thing on a scale. It probably has to do with disturbing the samples any more than what's already done. But once again, who knows? But see, Citizen, I'll tell you, your mind's in the right spot, because that's the right question to ask. You know, not, well, how much mass do you think you got? Well, why haven't you put it on a scale yet? That's thinking scientifically. That's how you should think. That's the good question. That's what the people should have asked, but they didn't. Because I oftentimes see news outfits ask questions that they think are pertinent, and I see journalists put in a lot of big words. They put a lot of big words in to try and sound like they're on the same level as these NASA scientists, and when they're really not. The best answers that you get from the NASA scientists are common sense, straightforward questions like yours. Those are the ones that should be asked. That's the ones that they're good at answering. That's why those students' questions in that press conference were so damn good compared to the dang media questions, because they were straightforward, very simple answers, because at the root of this is the scientific method, and the scientific method is rooted in common sense logic. It's very straightforward stuff. I want to figure out how much mass this is. Okay, weigh it. You could derive mass from that. Easy peasy. Right? Hey, Synthesis, thanks for the 24. And then during the meeting, Electron had a 86-month resub. Thanks, buddy. I appreciate it. Too enthused to open it up and didn't think to put a balance in the glove box. There's no way they didn't think of that, right? There's no way they didn't. So something is impeding them from putting this stupid thing on a scale. That's the problem, right? That's the problem. My guess would be disturbing the samples, but I'm not sure how, you guys brought up, like, I'm not sure, re-entry, they said that re-entry did destroy some of the rocks, because those rocks that have been sitting up on Bennu couldn't withstand the gravitational acceleration, so they actually crushed, some of the rocks got crushed in Earth's grav well, which is super interesting to me. I mean, I understand there's some real unknowns, but damn, that swing of how much did we get should be smaller. I don't know. Yeah, well, the other thing to take into account is, and this could be the reason, they haven't even begun opening up said sample. The tag SAM actually scooped up way more than they anticipated, and a lot of it got stuck to the point where they couldn't close the re-entry capsule all the way. They actually had to like crush some of the rocks to close the thing inside of the little capsule that came back down from Earth. So I think, so like if you think about it from that perspective, these rocks that they're dealing with now, NASA probably has a specifically calibrated scale, right? Probably have a specifically calibrated scale that's just designed to weigh the tag SAM and not all the crap that's around it, right? It's about being as scientific as possible. You got to be as straightforward as possible. You weighed the tag SAM before you left with nothing on it. So ideally, you want to weigh it again with nothing on it, which would that eliminates any possible margin of error, right? So, what's the first thing that they did when they took the thing off? They started clearing all the other samples off of that and started analyzing those, right? So my guess is that the experiment didn't the scientific experiment that they're running here didn't call for calibrating the canister with a bunch of crap on it. And you want to follow through with the experiment. One thing about scientific experiments is you don't change it. You don't change it just because you found something new. Follow through with the experiment and then start a new experiment, right? So, if it was me, what I would do, if there was crap all over it, well, I'd document all the crap that's on it, clean it off, and then weigh it, right? Which seems to be pretty much what they're doing from what I could tell from those press conference remarks, right? There you go. Perfectly logical explanation. That's what I mean. You know, for such abstract concepts that engineering and science deal with, the explanations are often rooted in very, very, very straightforward common sense, right? Follow through with the experiment. Continuity of your scientific experiment is important when you're doing scientific experiments. You have to follow through with your hypothesis. So that's probably the reason why. If I had to guess, that was just a guess. You know, I don't know. Maybe. Cool hat. New? Yeah, Havix, yeah. Right? Does that make sense, dude? Hey, Nazlik, I'm great. How are you? Yeah, Balbon, that's what I mean. This is something that, this is the kind of stuff that in Citizen, I'm not saying that you're a skeptic at all. That's the card that I play when I encounter people that are skeptical about science and engineering. I don't say, oh, well, you're an idiot, or, oh, well, yeah, you did your research on Facebook, pal. I go, no. The science that NASA does is remarkably rooted in straightforward common sense, right? Not the like, oh, speak when spoken to common sense. No, if you were doing a scientific experiment, right, you would want the continuity to be straightforward, right? If you're doing one here, like if I was doing one in my shop and I was worried about dust contamination, well, I'd make a chamber that has a filter in it so there's no dust contamination, right? It's very straightforward stuff. That's what I tell people. It's pretty straightforward. Like, there's no crazy overarching thing here. Like, they're, you know, they do throw around a lot of big words because, once again, the concepts that they're dealing with are very abstract. I mean, it's almost like, you know, when we're walking down a gravel path, you're walking down a gravel path, you know, you're just walking on rocks. But every single one of those rocks is slightly different. And it's super important to understand why. That's really important for what's called planetary science. But it's all straightforward, common sense stuff. Just seemed like a real wide margin. Well, they were thrown a curveball, right? They were thrown a big curveball. They got way more sample than they wanted. Now, and that's a good example when it comes to doing a scientific experiment or engineering, like when you're doing a test in engineering of how overperformance can sometimes not be a good thing. If you did the calculations for your rocket to have 5 kilometers a second delta V, and you actually go and physically launch it up there and it has 5,500 meters a second delta V, oh great, it performed better than you anticipated, but that means your math is wrong. That means your math is wrong somewhere, you know? If you have a car and you think that car is going to go 220 miles an hour or 340 kph, right? And it doesn't and goes 400 kph or, you know, 350 miles an hour, then, well, you didn't do the math right. Something you didn't take into account, right? You didn't take something into account. That's overperformance and underperformance in that regard is a problem, but as NASA said, it's not a bad problem to have. Getting more asteroid is not as bad as getting, you know, less asteroid. But they still said it's a problem, but it's not a bad problem to have. It's screwed with their experiment. They pulled too much. Not a bad problem to have. That's pretty cool. That's probably the reason why they haven't waited. That's what makes the most sense. That's what I mean, just straightforward. You know, that's the right question. Why the hell haven't you waited? Well, okay, so why wouldn't they weigh it? Well, scientific method. Straightforward. Great, extra performance. You've reached Geo rather than Leo. Exactly, right? Amazing that mix-up versus metric and imperial units still happen. I don't... What? Oh. Yeah, I just give both measurements. Both measurements are an estimate, guys, so bear with me. Luna 25 overperformed. It did overperform right into the ground. It was made reliable. It was unreliable. It was made reliable by the ground. By the way, the jackpot is now $1.73 billion. Well, I'm just going to have to go play it again. If they miss the launch tomorrow due to weather, when is the next window? It's a 24-hour recycle, Twisted, from what I understand. The Psyche mission is not... yeah, the Psyche mission, it's going to rain tomorrow on the Cape. It's going to rain a lot. They might have to deal with windage. When you feel it's appropriate, could you give an executive summary of the press conference? Yeah, here's your 30-second fill. So NASA did preliminary analyzation on the TAG-SAM component of the OSIRIS-Rex mission, which was an asteroid sample return mission from the near-Earth asteroid Bennu. The initial analysis showed that the rocks in the sample contained organic carbon compounds, clay with water stuck inside of it, iron sulfides, iron oxides, and I forget what the last one was. I think that's all of it. Yeah, it contained water. Water and carbon, the building blocks for carbon-based life, which is really, really, really interesting. Hey, Metric, 67-month resub. Iron oxides, iron sulfates, water, carbon compounds, organic carbon molecules, which, once again, that's good. Organic carbon, so, like, Ken Chang from the New York Times actually asked this question. Well, like, what's the difference between, like, organic carbon and then just, like, regular carbon? Well, it's what they find the carbon with, right? Hydrogen, oxygen, nitrogen. You find it with stuff like that. That's building blocks right there. Think about it like this. Like, a lot of things are made out of plastic, right? But are Legos made out of plastic? Yeah. Do Legos fit together? Yes. Absolutely. Does that mean that anything that's made out of plastic is going to clip on, like, stack onto a Lego kit? No. But what I'm trying to tell you is that NASA went to this asteroid and they brought back a bunch of Legos. You know, Legos, which are also carbon-based. Legos are made out of hydrocarbons, a little bit different. But you get what I'm saying. Like, they found stuff that could basically be building blocks of life, and it's theorized that, something similar to the composition of Bennu hit proto-Earth, and that is the reason why it brought, like, carbon and water to Earth, and that's the reason why our planet's slightly different than, like, Mars and Venus. It's called impact theory, and that sounds right. I mean, we've brought back samples of the moon. We obviously have samples here on Earth, right, of the ground. You can just go outside and scoop up some dirt, right? The interesting thing is that the samples that they brought back from the moon during the Apollo missions are very similar to the type of soil that you would have found on Earth couple billion years ago. It's not, I don't know the exact number, but the moon is made out of similar stuff, minus the life part, which is very interesting. This asteroid is made out of stuff plus the life part, but it's an asteroid floating in a vacuum. Yeah, a lot of new questions. A lot of new questions. Interesting. Clay minerals are hydrous aluminum aluminum so molecules formed out of aluminum and water or aluminum hydrates. They're hopefully also have trapped water pockets, but only thing they directly confirmed was the hydrates. Yeah, there you go. They found trace amounts, as Malak. Yep. I've heard the theory that much of the water on Earth here arrived from asteroids. Pretty much. It's called impact theory. That's kind of the prevailing theory as to why we are here. Phyllosilic. See, this is what I mean. This is why I didn't ask a question. I know nothing about geology. I know what vesicles are. And granite. And different types of rocks. But that's pretty much where my knowledge ends. Phyllosilicates. Well, hey, now you're just being silly, Flask, all right? I think that... I'm starting to think these scientists, people are making up words. The Bruins play tonight. Boo. Hopefully Bedard gets a hat trick on them. Hey, Pace. Hey, Pace. They got a cure for fuckstickitis yet? I should have a telethon for that. It'd really benefit you. Boom! I'll take my time out. Okay, cool. I don't want the cure. Oh, boy. Tigris, you find hockey to be easily followable while highly intoxicated. Right. An F1 car is going to be driven upside down. It should be able to do it. Cool. I spoke with the Europa Clippers project manager today, exactly 1 year, almost to the minute, before the mission's first launch opportunity at 11:51 a.m. Eastern Daylight Time on October 10th, 2024. Yeah. I just want to see the picture. Yeah, I think still got a little ways to go. Geology doesn't equal paleontology, right? Well, elevator guy, they have different names. Of course it doesn't. That's what I mean about that common sense thing. Geology, paleontology. They sound similar, but they're not similar, which means they might be overlapping. There might be overlapping fields there, or one might be a subset of the other, but they're not the same thing. You know how I can tell they're not the same thing? They have different names. You're welcome. Thanks for coming to my TED Talk. Okay, here. Couple of other things. Let's see. Gym time mission to Psyche. Lift off at 10:16 a.m. Okay, cool. Psyche, once again, does not have a high probability of launching tomorrow, but nonetheless, I'm going to be here early tomorrow morning. Just because it annoyed me and I had to look it up, here is the phonetic spelling of phyllosilicate. There you go. Phyllosilicates? Graboids? Graboids. Graboids. Broke into the wrong gosh dang rec room! Be like Bert. Have a rec room like Bert. Be like Bert. I want a rec room like Bert's. Don't we all? Don't we all? Here, check this out. Tube. 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 Was that flown? Yes, they are flown casings. They've been refurbed, though. Those are the 2 SRBs that are going to go to the California Science Center. There was a live stream when I started streaming today of them moving these things. The booster casings seem to be empty. There's just, I mean, they're obviously not full of fuel. If they were full of fuel, they would fall right through this asphalt, yeah. If they were full of fuel, they would crush this trailer underneath it. Fun fact. Can you tell me what you can do with those tubes? They're not aluminum, Panta. They're steel. I'd argue that those are defurbished. It looks like the insulator is in there. Believe it or not, Uncle Lux. It looks like they put the insulator from the outer lining on the booster. They put the liners in there. They just didn't put fuel in them. That looks very much like the insulator. No inhibitor, obviously, because there's no propellant in them. But those are definitely booster casings that have definitely flown, which is really freaking cool to me. But yeah, once again, they're also carrying the entire thing as a casing because it's light enough to carry all 4 segments together in a casing like this. Because if it was full, once again, it would, you know, like in the cartoons where they drop an anvil and the anvil goes through the ground? That's, yeah, yes, that's how heavy it is when it's fully fueled. I like that the SRB now comes with tail lights. Yeah. Yeah. There's no brakes on this train, though. Okay. Yeah, they are moving them to the California Science Center because they will be stacked with an external tank and the Space Shuttle Endeavour. They're building an exhibit. Sup, dog? They're building an exhibit at the California Science Center that is going to have a fully stacked shuttle, which is really freaking cool. Have you ever seen an airplane roll onto a surface it's not supposed to be on? Yes. Link it in chat, Havocs, please. So we can hump it? Yes, you can hump that. Sure, no problem. Do you see a sign that says you can't, LM? Vertical or horizontal? Boop. Any questions? Yeah, it's really going to be cool. Yep. The last fully complete shuttle stack. Real SRBs, real external tank, real orbiter, which just makes me absurdly happy. Should be like that at the Smithsonian. You will get zero argument from me. When do we move in? Yeah, right? That's really freaking cool, actually. Personally, I think it would have been awesome to actually have like build the mobile launcher into the building, cut up the ML, move it in pieces, and then build it at this building, and then bolt the shuttle to a launch pad that it actually used with SRBs that were actually flown, and an orbiter that's actually flown. That would be really cool, but we gotta go complicate things like this with this stupid money stuff or something. That was a joke. I get it. But, hey, fully stacked shuttle is pretty awesome. That's really cool. Yep. It'll be fully stacked. I'm just kind of wondering, like, I can't help but think in the back of my mind, how long? I suppose a shuttle stack could stay stacked indefinitely, right? I'm wondering how long can that thing stay like that before you have to, like, go up there and look at it? You know what I mean? I mean, it should be fine, right? Because think about the forces that stack has put on it during launch, right? During launch, during ascent into space, like, I'm pretty sure if it can withstand, like, you know, going into space and the aerodynamics involved with that and the pressures involved with that, I'm pretty sure it could just sit there for, like, pretty much indefinitely. Does that have SSMEs or are they dummy nozzles? They're dummies, Jim. Yeah. They're dummies. They took all of the Space Shuttle main engines out of Discovery, Atlantis, Endeavour after the flights, and they put duds in there. But, so, two interesting things. The reason why they took all the engines out is because they're using them for SLS. The second thing, the duds that they put in there are real. They're real engines. They just don't have, they're obsolete shuttle motors that basically, they're real nozzles. They're real engines. It just doesn't have all the parts. It's a dud. It's just basically the main combustion chamber, and that's about it. And the nozzle, they're real engines, but they don't have any of the plumbing. I'll show you. They're real. They're real motors. I just gotta see if we can find a picture of those. At least the nozzle I know is absolutely real, but it's just, once again, it's on a structural simulator. It's basically like an engine block used for a coffee table. Yeah, if you want to look at it like that, sure. I'm trying to see if I can find some pictures here. Yeah, I know they're real RS-25s because they pick up on the actual mount for them. But, once again, they don't have any... There's no plumbing on them. And it's kind of a... I think it's a dud main combustion chamber and a real nozzle, if I'm remembering that correctly. So... That's a really nice CAD model of a shuttle motor. See the MCC? So you have your main combustion chamber here and the throat is in there. And then you have your mounting point. The combustion chamber is gone. They took that off on these obsolete motors. And then it's bolted to basically a steel pipe. And that picks up on the shuttle's mount. Like that. That piece right there. I know there's pictures around of them somewhere, but... Yeah, they took all the motors out and put them in there. Hopefully they don't drop it as long as they hired a different contractor. Dude, I actually heard something about that. I know a lot of people that are in the aerospace hoisting business. Twisted, I heard something about that. Yeah, granted, this is secondary source from a guy who knows a guy that was working on that project. They were, so what I found is that, or what was told to me is that they were picking up on the proper hoisting points. Problem is the proper hoisting points were corroded to snot. That's why it snapped. Yeah, they were corroded to nothing. They were tensioning the steel cables up against the cut-up interstage, but the hoisting points, there is nothing left. There's nothing to hoist onto. That's the problem, because it had been sitting out for 50 plus years. That's why it fell. And that, it sucks, dude. It sucks that it got to this point. Historical preservation is something that I think is really important. And this is the reason why I'm so gung-ho about that, right? But yeah, there was nothing. They tried. They tried to pick it up like you should, and they couldn't. That's why they had to cut the inner stage. Because they tried to pull the inner stage off, and it just shattered into a bajillion pieces. So they had to cut it all. They had to cut it all up. That's why it was like that. So, yeah, it sucks. It sucks. But they took it apart, knowing full well that that could happen. That's why nobody was near it. If you notice the tagline is just basically a rope that's attached to the rocket so guys can pull it in one direction or another. So the crane basically has fine control to be able to drop it. If you notice on that replay of when they dropped the Saturn V, no one's on the taglines. And that's because they were worried about it coming apart. So they knew that that could happen. It's actually a pretty damn professional job given the circumstances that they got it that freaking far. Yeah, I actually went and looked into it because I'm like, something about this doesn't make sense. Why wouldn't they just take the rocket apart the way that it's supposed to be taking it apart? It's supposed to just be the reverse of putting it together. Well, there's nothing left. There's nothing left to hoist the damn thing. Yeah, it was just all corroded to snot because it's aluminum that's been sitting outside for God knows how long. Yeah, it sucks, man. It really sucks. It really... Mark it as debris. Good way to say that. I like that. Good way to say that. Alright, Havix, you link that thing. Alright, let me see. I told you to link it up. So, alright, let's take a look. At the behest of bringing out the crazies, let's see what's going on here. So this is on Reddit. Okay, what are we looking at here? You had to do a double take when you saw it. The report was 10,000 miles an hour at 70,000 feet. I'm just looking. Do we know if this was reported by any traffic? Because pilots, when they see stuff like that, they'll report it. They'll report the traffic because situational awareness is key. Havix, did anybody Anybody record anything like that? 70,000 feet, they won't see it? What flies at 70,000 feet? SR-71s, but SR-71s don't go that fast. I'm just looking around, I'm reading here. It's Mach 13, that's pretty darn fast. It's not fast enough for orbital, believe it or not. Where was this thing supposed to be? Like, where is this? It flew over France in 2 minutes at Mach 14 at 70,000 feet. I'm guessing it's just a glitch or something, dude. Like, there's no way somebody doing a Mach 14 test would do a Mach 14 test. Hey, ECO. Yeah, I've seen it. The Ariane 6 transport vessel. Yeah, it has sails on it, which is hilarious. It's a meteor? Nah, these flight radars and plane riders and ADS-B exchange, Jim, pick up on the transponders, the ADS-B transponders on the airplanes. So I highly doubt that a plane that's doing a Mach 14 test at 70,000 feet, the test pilot is going to forget to shut the ADS-B transponder off, right? Why the heck would you even have an ADS-B transponder on that thing, right? You don't want anybody to see it. Why would you do a test over such a public area? See what I mean? That doesn't make sense. If it's something you didn't want anybody to know about, you wouldn't test it over France. Spoiler alert. Or even Europe. There's a lot of people there. People would have heard sonic booms, right? Maybe it's not a test, Monkas. I think this is just a glitch, Havocs. Pilots would have reported this. People would have seen it. People would have heard it. I want to believe that it's the successor to the SR-71. I mean, if we want to put on the tinfoil hat for a second, I refuse to believe that we don't have a plane that goes faster than an SR-71. I'm pretty sure we do. We have one that we know about. The space shuttle goes way faster than an SR-71. 5 times as fast. So, just saying, probably, I'm pretty sure they probably have something quicker. I mean, if you want to be absurdly realistic, yeah, of course they do. Satellites go way faster than an SR-71. And they do the same thing. That's the reason why we stopped flying it. Go figure. You know, could be TR-3B, Aurora, it could be a bunch of things. But it's most likely nothing. The French would be the first to complain about noise and try to cancel it. Yeah, it is making too much noise. How dare you make too much noise? You idiot, but with this thing we can get a leg up on all of our enemies. No. It is making too much noise. It is interrupting my cheese and wine time. No. No. You don't need a plane like that anymore though, right? I mean, I don't know. Maybe. TR-3B is speculation. There's no confirmed sightings of it. Yeah, that's kind of the point. I know. I mean, Josh, let me put it to you like this. Yeah, satellites replaced it. We don't have any need for it, but I'm failing to come up with a, adequate reason why you should surrender that capability. You know what I mean? But, on paper we did, right? Why would you do that? You know? I'm getting really freaking tired, dude. I've been up since very early this morning. Any need for it? How about redundancy? I'm sure somebody somewhere has some use for it. Just like the F-117 that supposedly has been retired, but yet we just keep finding pictures of it flying around. Weird. Yeah, it's probably just spoof data or a glitch or... I mean, ADS-B glitches out on me all the time. That happens all the time. You see weird stuff flying around. Like, there's always weird stuff flying around on this thing, dude. Look at all the freaking planes. My favorite part about zooming out on ADS-B is that you can see the high altitude highways. Ow, that was my toe. A lot of people don't know, just on a side note, that airplanes have highways. Above 18,000 feet, there are highways at different levels. Really, really cool stuff. Yeah. Now, don't get me wrong, there are low-altitude airways, too, but most of the highways are up above 18,000 feet, which is really cool. That's where the boundary, that's where the border between VFR and IFR happens. So there's actually highways up there, and you can see the planes on the highways, which is really cool, just like a road. See? Look. There's traffic. I always thought that was really cool. Right? That's really neat. I think that's really freaking cool. There's all kinds of good stuff. Yeah, see, there's another highway right there. That one, this one on the Atlantic sees a lot of traffic because all the flights that go from Europe, right? All the flights that come to and from Europe, there's 3 different lanes right there. This one that goes down the Atlantic seaboard, look, you can see it. That's really freaking cool. To, you know, for all the people that from the UK and from Europe that go on holiday down in Florida. And even if you're going to like South America or something, they usually still take that highway. Because that's the one that skirts land. Like, see right here, this you're flying next to land for most of the time. That's why they do that. I mean, don't get me wrong, you could still use these. There's a bunch of planes using other highways, but the majority of the planes fly over here. Yeah. ETOPS, indeed. Yep. Ah, yes. Island. It's still weird that I can say that I've been there. It's even cooler that it's a straight line from Europe to the States. Yep, dude, look at that. But see, you see weird stuff all the freaking time, like that. You see strange stuff going on all the time. Like, what's going on in Saratov there? I have no idea. We don't know what that is. There's always weird stuff like that. You know? Always. It could be a drone with an ADS-B transponder? That's new to me, but then again, I don't know much about drones. Yeah. The highways are everywhere, too. You can see them. They're just lines of planes. Check that out. Look at the approach for Heathrow. Talk about traffic. That's crazy, man. Fun. Okay. Let's see who knows their stuff. Which way is the wind blowing? The wind is blowing east. Always have a headwind taking off and landing. It's blowing from that side to that side. Yep, that way. Pretty cool, huh? Yeah, see? So, okay, quick thing. Runways have basically like a or airports, basically, it's not exactly like this, but it kind of is like this. So basically, and forgive me, pilots, I forget the exact name of it, but there's basically a roundabout around every airport. There's a ring, right? And depending on what direction you come in, you basically get to that roundabout, and then you circle until you're lined up with the runway to land. I forget what that's called. That's why I'm using car terms, but it's a approach pattern. I think that's right. That sounds right. But yeah, that's kind of how the whole thing works, and that's every like big airport. Like if you go back over across the pond, yeah, of course Logan is a freaking cluster, right? The wind is blowing north because they're landing planes on 21 left. So the wind's blowing that way around Boston, right? But the planes basically will get near the airport, and then they'll circle around for the runway. Like that JetBlue plane is circling for a runway. See? Actually, this flight path is, yeah, this one goes by my house all the time. I see planes on this flight path all the time because it's down here. See, they're out over Plymouth. But yeah, see, once again, you see weird stuff like that all the time on ADS-B. So, like, let's check it out. Where's that JetBlue plane going? It looks like that JetBlue plane is circling around to land on, actually on runway 27. That guy's targeting this runway right here. But yeah, the outer circle is like right here. Any plane that's like on approach right here, see? That guy got to the outer circle, entered the approach pattern, and then turned for alignment with the runway. Where did that guy come from? That Delta? That's a Delta flight. Where did it come from? Wow. Oh, came out of O'Hare. See? Seattle Metro is fun because all the airport runway. Yeah, SeaTac. There's no east-west runways. I mean, Soapbox, you ain't fitting it in there. The runways are on a plateau. I've landed at that airport before. Yeah, it's kind of a trip, dude. Can you turn on all the airplane's flight paths? It's depending on which plane you click on. Let's see, there's a guy in a Robinson, an R-44 that flew out of Beverly over there. He's following 128, which is funny. It's not an outer circle. There are arrival, fixes, transition, and approach. Basically published procedures. It's not kind of like an outer ring. It's like when you get near the airport, you kind of skirt around. You kind of fly like a half circle all the way to almost to the runway. But it's not exactly like they're entering a roundabout. That's, like I said, that was Twisted. That's not like the exact way to say it. I know that. I know I wasn't saying the right thing. Planes! Ask it IRL ATC, not US-based anything. Yep. Yeah, so oftentimes, like, if you picture that loop that I was telling you about that doesn't exist, the plane won't go here and enter the loop. It'll just fly over here and turn around like that. See? It kind of, yeah, you basically just turn until you get lined up with the approach. That's interesting. See that? What's that plane doing? Cap 516. Cap 516 is on approach from... Where did he come from? Must have come from up in Maine. The ADS-B stops near Trenton. See, that plane entered the pattern before him. See, this is just ATCs doing their thing. What happens when you have two runways at 90 degrees to each other and the wind is blowing across for 45? Pick one. You can get some firework. Planes can land with a crosswind. It's totally doable. Planes can land with wind going 40, like, they can land with wind going 90 degrees to the runway. It happens all the time. But yeah, if it's 45 degrees, so like see, you know, you have 21 right and 21 left right there. You'll if the wind was, you know, but see also there's 27 That's runway 27 right there. The wind is probably blowing this way, and they could probably get away with landing both planes, but it's kind of at the tower's discretion. And that's where the meteorologists really come into play. There's meteorologists that work, tons of meteorologists work for the FAA. Yeah, making sure that planes have the right weather reports, etc., etc. It's super freaking cool, man. And these aren't like the meteorologists that you see on the television. These are aviation meteorologists, which are, let's just say those guys don't get it wrong. Let me put it to you like that. Yep, see that JetBlue plane that we were just looking at? See, he circled out and in. And look, there's another plane right behind him. And the air traffic control, so the tower here is constantly talking to all these different planes, because the planes will get near the tower and they'll, you know, the tower will tell them what runway to land on. I mean, it's still a pre-planned flight. They have to follow the flight plan, but you still have to ask the tower. You do not get near any of this. You don't get near any runways on the ground or in the air without the tower's clearance. That's how people die. So ATCs are constantly, it's like playing tower defense, dude. They're constantly vectoring planes in and slotting planes in for landing and takeoff. And then that's just the tower. You want to get on the taxiways and stuff, you're talking to the ground control. The ground control is what all these guys are communicating with until they get to what's called a runway threshold. The ground will vector them to the right threshold, but you have to radio the tower to cross that runway threshold. It's called a hold short, basically. You cannot cross that hold short without asking the tower. That is like rule number 1. Don't have an incursion onto a runway without the tower's approval. That's how people get killed. Don't get near the runway unless the tower says you're supposed to be there. See, like these planes right now, they're still communicating with the tower here. They're still talking to the tower, right? Because they have to cross that runway. And then the tower will tell them to contact ground when they, get over here. LA runways are even crazier because you have 2 approaches to take. Yeah, exactly. San Francisco and LA, you can have 2 planes landing right next to each other and 2 planes taking off right next to each other, which is super cool. Is it ground for the cross runways? Yeah, my fault. You talking about this? What? Yeah. Well, we can talk about this. So check this out. This was back from the beginning of this year. This is precisely why you don't ignore what the tower has to say. Listen. Okay, so watch AAL 106, all right? And listen.
Runway 4 left, Delta 1943.
No audio.
American 106.
Oh, there is audio, excuse me. My headset's off. Here, let me back it up.
Clear for takeoff, runway 4 left, Delta 1943.
So, the tower cleared for takeoff, DAL 1943. So they cleared that Delta plane down here for takeoff, and the pilot started to go. And what the shoot? Oh frick! Is the pilots saw that. They saw AAL 106, American Airlines Flight 106, which is a 777. That's a huge freaking airplane. You can't miss it. These guys are freaking going, oh shit, hit the brakes. See?
American 106 Heavy, American 106 Heavy, hold position.
Yeah, see, that's the tower going, no. Because this guy crossed a hold short without clearance. Bad. That's what I mean when I say this is how people get killed.
106 Heavy, hold position.
Delta 1943, cancel takeoff clearance. Delta 1943, cancel takeoff clearance.
Rejecting.
Yeah, see, those guys on the Delta plane knew exactly. They were like, no! That came about that close from being real bad, real fast. Oh yeah, this is why, yeah. ATCs, man. Those guys They're doing a lot of work. Flight sim, you know. This is why you don't cross onto an active runway without the tower saying to. Hey, Arsenal, what's up, man? Yeah, this is full brown pants. That brown pants moment. Full clip with the tower post-incident. Oh, let's see. Like, that's one of those just concrete rules. Don't do that. All right, here, let's listen. We listened to this a year ago, but...
American 106 Heavy, Tango Alpha for taxi.
So Tango Alpha for taxi. Tango and Alpha are the different taxiways. So runways have numbers, and taxiways have letters. Just for anybody that doesn't know.
106 Heavy, Kennedy ground, next 4 left, taxi left, Bravo.
So 106 Heavy, this is Kennedy ground. So ground is talking to that plane right now, AAL 106. Note that 106 has a heavy designation. Heavy designation, well, means it's heavy. Means it's a big plane. What? Kennedy ground, runway 4 left, taxi Bravo, holds short of Kilo. So, taxiway Bravo holds short Kilo. So, they told them to stop, basically. Ground told them to stop.
Hold short Kilo. Hold short Kilo, American 106.
And the pilot replied, hold short of Kilo, American 106. And then precisely didn't do that. Arsenal, you got an interview at a cool spot doing political work in D.C. I told them I wouldn't be able to start until I graduated in May. They told me to email them for an interview a week before I graduate. Oh, there you go. Which taxiway is Kilo? Latte, if I'm remembering correctly, when I looked at this originally, they took Kilo's this way, and they took a right when they should have taken a left. If I'm understanding that right. They went on the wrong taxiway.
American 106 Heavy, cross runway 31 left at Kilo.
Yeah.
Delta 1943, wind 35018, gust 24, runway 4 left, clear for takeoff.
That was the tower clearing 1943 for takeoff. This guy down here at the bottom of the screen.
Alright, clear for takeoff, runway 4 left, Delta 1943.
I'm laughing because people didn't get killed. It's funny because people didn't die, but also never do this. Yeah, let me see the Jepson. Hold on. I gotta look at the Jepson map. I'll be able to tell you. So... Yeah. Yeah, 106 screwed up bad. They said hold short Kilo tax on runway 31L. So they said stop right here. See where the K is? Yeah, 106 was on Bravo and turned to Juliet and crossed the runway crossed 4 left. Yeah, yeah. Ground didn't do anything wrong here. Ground told them where they need to go, and they just decided to go off in their own direction. That's 106 Heavy's fault all day. Did anyone get fired for that? No. I don't know about the internal policies for if you screw something like this up, but the FAA will definitely be talking to you. Because, you know, they have a number for you to call, right? That's when you did something wrong. When the tower or ground says, or a center says, yeah, this is, we got a number for you to call. What that number is kind of, basically they're trying to figure out what the hell happened. The FAA is always, basically puts all this under a magnifying glass all the time to make sure that this was just a stupid mistake. Like, is it pilot error? Is there something wrong with the taxiways? Did the radio not work? Every single incident, especially these ones, gets investigated. And part of that, and part of the job of the pilot is to tell them, like, you know, Okay, why did you turn on to Juliet when they told you to go on to Kilo? Burbs, 54-month resub. Harrison Ford had his local number memorized. How long did you have that teed up, Edmana? How long did you have that teed up? All right, so yeah, 106 should be over here. Let me hear what 106. Where did 106 come from?
Grand American 106 Heavy Tango Alpha for taxi.
I thought Tango Alpha would be for taxi. I may have misinterpreted that. Hold on. Like 30 minutes. Nice.
Six Heavy Kennedy Ground, next 4 left, taxi left.
106 Heavy, Kennedy Ground, runway 4 left, taxi Bravo, hold short of Kilo. So AAL is coming, 106 is coming from where 185 is coming, so taxi Bravo holds short of Kilo. So they told them to stop right here. Basically right there, stop, don't move.
Bravo, hold short of Kilo. Bravo, short of Kilo, American 106.
And yeah, Kilo's this taxiway right here. That's Juliet right there. That's, yeah. When they tell you to stop, that means stop.
American 106 Heavy, cross runway 31 left at Kilo.
So, ground just gave clearance to go here, to cross right here, and they're not doing that. Yeah, and the pilot acknowledged hold short as well. That's, not ground nor the tower's fault. That's that crew's fault. So, yeah, pilot got confused. They thought that was Kilo. Kilo's over here.
Delta 1943, wind 35018, gust 24, runway 4 left, clear for takeoff.
Now, the tower just cleared 1943 for takeoff, figuring that 106 is over here when they're over there. This is why you don't cross the runway. They went past Kilo. Kilo's right there, and they're on Juliet. They're on Juliet crossing runway 4 left instead of on Kilo crossing runway 31. Or 31 left, excuse me.
Alright, clear for takeoff, runway 4 left, Delta 1943.
American 106 Heavy, American 106 Heavy, hold position. American 106 Heavy, hold position.
Delta 1943, cancel takeoff.
Oh, that stresses me out.
Delta 1943, cancel takeoff clearance.
Rejecting.
Delta 1943, same intentions.
Yeah, we're gonna have to go somewhere, run a couple of checklists, and probably make some phone call for Delta 1943.
Delta 1943, taxi right on Bravo, hold short of Hotel Bravo.
Right on Bravo, hold short of Hotel Bravo, Delta 1943.
Oof.
1943, Kenny, did you make the switch?
Yes, sir, we did.
Okay, I'm guessing you don't want to move, right?
Well, we gotta make a couple phone calls here. My guess is we're gonna go back to a gate.
Okay, I'm figuring that as well, all right.
American 106 Heavy.
106 Heavy, go ahead.
American 106 Heavy, possible pilot deviation. I have a number for you. Advise ready to copy.
That's pretty funny. That's possible pilot deviation. That means you did something wrong. We have a number for you to call. That's the nice way of saying it.
American 106 Heavy.
American 106 Heavy.
The last clearance we were given, we were cleared to cross. Is that correct?
American 106 Heavy, we're departing runway 4 left. I guess we'll listen to the tapes, but you were supposed to depart runway 4 left. You're currently holding short of 31 left.
Roger, American 106 Heavy.
That's right there. Right there is when they knew they screwed up. Roger, 106 Heavy. That, yeah, you could hear the pilot's, the co-pilot's voice just go, oh. Oh. Delta 1943 had brakes that at 1500 C, they needed to tow it to the gates. I believe that. Dude, yeah. No, this doesn't look too bad, right? This doesn't look too bad. Planes don't stop very well. That's why they need long runways. They can't stop on a dime like that. That's a lot of momentum going down the runway, especially right there. DAL 1943 and AAL 106 are both passenger planes, dude. So that's a 777, and that's a 739, which is a 737-900. Heavy is, so AAL 106, it's November 754 AN. We can actually, here, November 754 AN. That's a 777. That's a big airplane, dude. 777s are huge. They're almost as big as a 747. Actually, it's about the same size. Yeah, here. There's some good reference, and that's actually at Logan. That's Winthrop in the background. Look at it compared to the truck. It is a freaking chonker of an airplane. That's an older 777. Yeah, you can tell because of the winglets. Or lack thereof. That's an older 777, so it's a Dash 200. Yep. So, little bit of reference here. That's 737, so Delta 1943, its fuselage is the diameter of that engine cowl. Yeah. That's how big a GE9 is. The GE90, that's a huge engine. Yep, GE90, that diameter right there, the wide diameter, right at the intake of the cowl, that's as wide as a 737's fuselage. So that should tell you how bad that almost was. But yeah, the AAL 106 screwed up bad. Like, bad. American was probably like, what were you doing? Posting on Insta? Yeah, probably shouldn't do that when you're flying. Supposedly, there's a reason why they had a mix-up. All right. Yeah, there's an ad block thing, so I don't care. I can't see it, Uncle X. It's just getting all antsy about the ad blocker. You streaming the heavy launch tomorrow? Oh yeah, absolutely. Yeah, you know, because that's good. That's gonna make me more, you know, enthusiastic about going to that website. Yeah, no. Yeah. Those are the sizes of the two planes that are involved right there. Yeah, see? Look. Like I said, the fuselage is as big as the frickin' engine. The GE90s that are on 777s and even the GE9X, the GE9X that's on the 777X is gigantic. That's a big motor. So, you want some other reference? That's the diameter of Falcon 9 right there. Yeah, that's how big that motor is. Want something even crazier? That motor almost makes as much thrust as a rocket engine, as like a Merlin 1D. It actually, it's making about maybe a third of the thrust of a rocket engine. Actually, maybe not a third. Hold on, let me check just to make sure I got the numbers right in my head. Yeah. See, check this out. G90-110s are making up to 513 kilonewtons of thrust. That's half of a Merlin 1D engine, which is absurd for an airplane. That's an absurd amount of thrust for one engine, for a turbofan. There's not many motors that can make that much thrust. 115,000 pounds of thrust, which is just, all right, okay. You ever flown on a 777? Yep. Yeah, I've been on a 777. I flew on a 777 from Tokyo Narita to JFK, New York. Let's see last here. Alright, well, let's take a look. Once again, I covered this before, but yeah, it's important to understand how this all works. Havoc's, if you're still here, started a pretty lengthy discussion on this, which is cool. I don't mind doing stuff like this. This is sweet. The first officer on AAL 106, which was involved with a runway incursion on Friday night at Kennedy, was flying her first flight with new cockpit procedures. At the time of the incursion, which forced the DAL aircraft, so that's 1943, to stop suddenly, the first officer was engaged in a series of tasks that involved processing takeoff data that included flap and power settings as well as a runway assessment. You assessed the wrong runway. What's wrong with you? But for the first time under new procedures introduced on January 2nd, she also had to make an announcement informing passengers and flight attendants of the impending takeoff, said the source, a pilot who was knowledgeable of the incident and asked not to be named. The procedures required the 777 first officer to inform passengers and flight attendants that takeoff is imminent. The announcement was previously made by the captain. It requires the first officer to interrupt continuing tasks, be precise on timing, and change intercom settings. The first officer, an experienced 737 pilot, was making her first 777 flight after 100 hours of training flights that did not include new procedures. See that right there? That's why the FAA investigates this stuff. That particular reason. Because now the FAA is going to get up and probably got up American Airlines' tail and said, what? You know, the co-pilot's job in this particular scenario is to make sure that, you know, your plan for like taking off is good. But no, we gotta tell the people in back that we might be taking off soon. Yeah, see, that's not 106's fault completely. That's some bozo who probably has never flown an airplane coming up with procedures. Oh, well, we can save 5 minutes of time. 5 minutes of taxi time if we have the co-pilot tell people instead of the pilot. It's just like, all right. Yeah, that's why they investigate that stuff. That's why they have numbers to call. That's why they tell you to, you know, we got a number for you to call. You're not in trouble because it might not be your fault, right? So I'll bet you nothing happened to the pilots on AAL 106. I'll bet you nothing happened. That's completely American Airlines' fault. You're setting your pilots up to fail. You trained your pilot on the previous procedures and introduced newer procedures when people were on board. Are you high? What the hell's the matter with you? What? Are you crazy? What are you, nuts? Like, okay. Oh. Yeah, anyway. Cool thing on towers and all that. That's really neat stuff. I'm guessing they immediately switched back to old procedures. Yeah. To think switching who makes the announcement, if done wrong, can risk hundreds of people's lives. This is why rules and procedures are important, especially with airplanes, dude. You don't screw around with that. In fact, Oculus, do you remember when we had that conversation? Where I basically said something along the lines of, look, if something is going wrong with an airplane in the air, that means somebody did something wrong on the ground. Right? Air incidents like that there's no excuse for them to happen, right? There's no excuse. And dude, ever since I've had that conversation, I can't really unsee it. You know, you see stuff on the news about, actually, I forget where it was, but a plane had to belly. They had to belly a plane on a runway. I forget where it was. They bellied a plane on a runway. Some pilots, a plane with people on board because the landing gear didn't come back down. There's no excuse for that. So does the FAA look over procedure changes by airlines? If not, why not? This kind of thing could be prevented if someone at the FAA saw it. I'm pretty sure they have to get that kind of stuff approved, drummer. Was it a FedEx plane? Yeah, okay, so, I mean, the only people on it were the crew. Well, that's good. I don't know if you guys saw this, but it's pretty insane. Maybe I showed it on Space News or something. Here, check this out. Let me see if I can get some footage here. Watch this.
Give me 2 engines ready to go. Okay. Hey, y'all get ready.
Holy sh! You hear that? That's the sound. That's the sound of thousands of dollars worth of engine being ablated off. Yep. Ooh. Oh. That probably voids the warranty. Actually, the pilots did a pretty good job landing the damn thing. From what I saw, they actually... It's not too bad. The plane actually they landed with both the engines still attached, which is pretty freaking cool. Yeah, here, look. That looks like a 757. Yeah, see, look at that. Not bad. Not bad at all. Good job by the pilots, dude. Yeah, I watched it, Squish. Mm-hmm. Not bad. Seriously. I'm impressed. And I love this step ladder. Step ladder up to the freaking door. Wow, that plane is remarkably intact. That's pretty cool. Oh, flaps were set right. Nice. The fact that that engine cowl is still in one piece is actually pretty damn impressive. Cool. Yeah, that engine probably won't buff out. Let's be real. Guessing the plane will be scrapped. Actually, Drummer doesn't look too bad. To be 100% real, I would take that whole thing apart. You don't know what kind of stresses you just introduced to it because, you know, the engines are not designed to hold the plane up. So you may have broken something. That plane needs to be onced over. It needs to be onced over completely because you can't screw around with this stuff. You know, like, and sometimes, sometimes if you know, FedEx is just like, screw it, it's an old plane. Sometimes taking the entire thing apart and putting it back together isn't even worth it, so just junk it. Get rid of it. The left pylon collapsed. Yeah, that's what I mean. Airplanes can look like they're relatively intact, but that, I mean, it's obvious at this point. That plane's nowhere near airworthy. Not even close. I would not fly on this. I mean, most people wouldn't, to be fair. Also, that's a shame. 757s are cool airplanes. There's a variant of a 757, dudes. I forget which variant it is, but there's a variant of the 757 that has the same engines that a DC-10 has on it, and it goes fast. Let me put it to you like that. It goes fast. Yeah, parts plane. Yeah, exactly, Thump. Part it out. Take all the good stuff off. Junk the rest. But yeah, see, like, the landing gear not deploying, that's ground maintenance all day. When was the last time that plane was inspected? And it's there's one of two answers to that question. Either it was a long time ago, or it was very recent. Because plane landing gear just doesn't magically malfunction. There's always a reason. It doesn't magically just go, yeah, I'm not going to work today. Nope. Either somebody did something really recently, or it hasn't been looked at in a really long time. It's one or the other. What are you saying? This is airworthy. Nah. Nah, I don't think it is. But anyway, yeah, dude, I don't know. Like, on a quick side note, would you guys be interested in just watching ADS-B? I think this is super cool. Like, I don't think it necessarily would be something that we would do all freaking day, but it's really cool to see this stuff come in and land. Yeah, see, speaking of 757s, November 14120, United Airlines, 752. Where's that guy coming from? Oh, wow. He came a long freaking way. SFO. Cool. Can you search Squawk 1255? Nope. Yeah, watch it in Flight Simulator. Anything over Hearts of Iron. I might just play more because you don't want to see it. Yeah, see, this is what's going around my neighborhood. Oh, what's going on out here? Training. There you go. 2 UH-60s. Cool. They're doing training. Oh, that's cool. You can see, you can find stuff like that. When mill stuff is doing training, they keep the transponders on, which is really freaking cool. You can see all the cool stuff that they do. Driving into a tornado in Wildwood, Florida. Yeah, you probably shouldn't do that. What do we got here? Dash 400. Dash 400 cargo. That guy's probably is coming. Where's he coming from? Luxembourg? Dude. Cool. Oh, and there's another one. Oh, hey, look, there's another one. Click the U in the top.
Discovery, go at throttle up.
Check off the coast of North Carolina. There's a P-8 doing circles out there. Yeah, let's see. Oh, yeah. P-8 Poseidon. Yep. Yeah, that's definitely training. That's training ops. He's either that or he's doing circles around something in the shipping lane. The U is for mill only. Oh, that's cool. I mean, I know what people are going to say. Why would the military say where all their stuff is? This is stuff with the transponders on. If the transponder's off, yeah, they're not going to show that. But, oh, there's a Chinook flying around Lake Champlain. Cool. Hell yeah. CH-47. Sweet. KBOS Tower Radio. Yeah, that's pretty cool. Someday, chat. Someday we'll be doing this for rockets. Someday. Oh, that UH-60 flew out of Windsor Locks. Anybody know what's in Windsor Locks? Who knows? Oh, TARS, that's cool. Bradley, yep, there you go. And my new house. Oh, and your house, Canuck? Nice, so there you go. Neat. Yep. Where's, Fairly International. Not the freaking Chinook. I've heard this thing's blast over my house at 1,000 feet every day for the past 10 years. Oh, come on. Don't you love that noise? Yeah, dude, this is rad, man. I could do this all day. Where's that chopper going? Places. Anything working around Wallops? Nope, nothing's flying around Wallops. Other than a JetBlue A320. I wonder where that guy's headed. They have F-35s at the Air National Guard base in Burlington. Cool. It shakes your house. Good. It's supposed to. It's just a reminder that we make better helicopters than you. Constantly. Southern Alabama is crazy for military chopper training. Whoa! Cool. Look at all this stuff. Look at all of them. Cool. Oh, that guy went off transponder. Yeah, a lot of UH-60s flying around out there, and there's a lot of EC-145s too. I don't know if you've been around the Bradley area, but the A&G base got a big overhaul. I haven't, Canuck. Interesting. Yeah, there's all kinds of stuff flying around out there. That's cool. You could go to the airport and stream live. Yeah. That'd be pretty neat, dude. Some stuff's going down around Jacksonville. Yep, see? Training. They're doing training out of Cecil Airport. Anything down at the Cape? Nope. There's a guy on a 172 just flying up the causeway there. Might be time to get back into flight sim. Yeah. And then there's MCO. MCO is nuts. That's a really busy airport. Last time we were looking down here, I saw a guy flying a P-51 around. It had a very different icon to all the Cessnas and whatnot. I don't think there is any, though. Cecil is a naval air station. Makes sense, Tech. It's a bit staggering when you zoom out the whole U.S. and you see just how many military aircraft are training all over the U.S. Oh, yeah, there's tons of good stuff. Oh, dude. Big boys flying around. That's the big boy right there. Cool. That is a chonker of a freaking airplane. Where did he fly out of? Oh, I flew out of Travis. Okay. Yep. Travis has an extremely long runway. I wonder where that guy's heading out to. There's Globemaster 3s freaking everywhere. KC-135s. Another KC-135. Yeah, dude, C-17s, man. They're all over the place. That one's an RC-17, though. That's not a C-17. It's an RC-17. It's Canadian. See? RCH 945. Actually, no, RCH is not Canadian, even though the R kind of is. The R makes it look like it, but it's not. Yeah, see, there's all kinds of good stuff. Ooh, T-38, like somebody was saying. Someone's doing some training. And that guy flew out of Newport News. Langley, yeah, okay. What is that purple over Portland, Maine? It's probably a Gulfstream or something. 560 citation. Cool. What about over here? Anything flying around? A couple of C-130s. Ooh, Lynx? Cool. Some Lynxes down near Cornwall. That's pretty neat. I'm not going to pretend like I know how to say that. Yeovilton? See last, please. Okay. On the 14th and 15th, look at the Santa Maria Airport as an air show is supposed to be happening. Cool. Yeovilton. Got it. Cornwall. Drummer, can you hear these things flying around? Don't answer. Don't answer. Yep, see? Another C-17. That one came out of, yeah. Rezau. Yep, we know why that was there. Okay. Yep. That's probably where that other C-17 is going, just saying. But, yeah. Cool. When do you think we'll see stats return to the skies? Oh, SSTs return to the skies. I don't know, man. It really depends. Check it out. What's up, Dish? You're watching me on your Tesla? That's weird. That's crazy. Your bet has been Ben-Gurion? Nah, Rezau. That's Poland. There was some C-17s that flew into Ben-Gurion a little bit earlier at Mena. It was a couple of days ago. Yeah, A400. Kaka. That's Kaka plane. Some guys flying T-38s around. Definitely training. Where are they flying out of? Gulfport. Gulfport, Biloxi. Yep, yep. Actually, we could go look at Johnson, see if anything's flying out of Ellington. We could usually figure it out. No. Oh, there we go. November 960. NASA's doing flight training. They're doing touch and goes. Cool. Where did that guy come from? That's astronauts. Astronauts are flying that plane. Yep. Somebody's doing some flight training. Oh, yeah, latte. I see it. Yeah, see? They're doing touch and goes. Cool. So, see, okay, check this out. Guys, any plane that has an NA designation, so November 3 numbers NA is NASA. That's a NASA airplane. So, freaking fly. Those are NASA T-38s. So 967 NA is a NASA plane. See? It's a T-38. It's training. New astronauts fly around on this. They all get started to fly around in a T-38 because it's good to learn how to fly something so like when you go up into space, because operating a spacecraft and operating an airplane are kind of similar. They're not exact. It made more sense when they flew the shuttle, but see over here, 960 NA. That's another T-38. It's painted the exact same as that. So those are NASA airplanes flying around, which is pretty cool. Anything else flying around? 2519. Oh, 924 turned on its transponder. Cool. So check that out, dude. We can see touch and goes that are going out of Ellington. Like, that's pretty wild, man. The future's pretty freaking cool, man. You know, like we always say, like, oh man, I really would have lived to see this, but that's pretty neat that we can actually see this. They were also used as chase planes for the shuttle. That's right, Crunch. Yep. Mm-hmm. You see, NASA doesn't show up in the military stuff because NASA isn't a military outfit. It's a civilian agency. So 924 just turned the transponder on. I wonder if there's another one behind that one. There's a DC-3 flying off the coast of Wallops. Crunch, your dad is a T-38 pilot. That's cool, man. Off the coast of Wallops, so up here? DC-3, huh? A plane from 1944 is just flying around out there. It's just a plane from 1944. That's cool. November 161, Papa Romeo. Cool. C-130 just chilling out there. That's really neat, dude. See, you can always spot some cool stuff flying around. Like, dude, can you believe that? Some dude today was just like, you know, I want to go fly around in my DC-3. I'm going to go fly around in my DC-3. All right. Sweet. It's just a, I mean, it's just an 80-year-old airplane. Almost 79 years old. Whatever, let's fly around it. It'll be fine. What's the weather like out there? Guessing it's a flight for just keeping it going. Nah, drummer, that looks like a training flight. To be honest with you, that looks like a training flight, dude. Because yeah, training flights don't really have any rhyme or reason to them, you know. Either that or the guy's just demoing the plane. He just said, "Hey, give me $20 each and we'll go fly around in the airplane." Either that or the guy just wants to fly around in his DC-3. That's always so wild to me. That there are people out there that are just like, you know what, I feel like flying my plane around today. Alright, I'm gonna go fly my plane around today. Okay. Ooh, somebody else is, what's that? Somebody else is flying a T-38 around. Yeah, we saw that one before. You too could be one of those people, yeah, with some time. The TX, Kurlani? Yeah. Oh, what's going on down here? Yep, see this? That one right there? Training. Training flights all day. It's probably an SH-60 if I had to guess. 206 Jet Ranger. Yep. Training. It's just training all day. All day, every day. Yep, Eglin. Cool. So, Eglin Air Force Base actually has... It's really interesting if people don't know. There's just a bunch of airfields. They're called auxiliary airfields around the main airfield, and they're just used for training. Yeah, like doing touch and goes and stuff. It's actually super cool because they're entire airports that are just there for training. Like, they don't actually do much, just touch and go, and I mean, they use them for other things too. Fun fact, you guys know that footage of the C-130 with the SRBs attached? That's where it was tested. It was tested on one of those weird airfields. See? They're just big flat patches. They use them for any type of training. They're like, the airfields aren't necessarily airfields, but I mean, Duke is, that one is, but the other one's like down here. It's just a couple of runways just sitting in the middle of nowhere. I mean, they're marked X so people don't land on them, but they still do. They do all kinds of crazy stuff down here. Another C5 just flew out of Travis. Cool. Yeah, see all these little auxiliary fields? Cool, huh? They use them for, they train on them. See, there's just another runway just out in the middle of nowhere, just doing nothing. But check, oh, well, we know what that one's for. Who knows? This is an easy one. Who knows what that's for? The markings on the runway, on runway 18 there. Carrier touch and goes. That's practicing carrier landings, dude. That's cool. That's really cool. And I'll bet you the runway from the other side has it too. Yep, there you go. 36 has the same thing. Cool. Yep, that's the same kind of... That's what the landing runway looks like on a carrier. It looks exactly like that. Yeah. Freaking wicked, dude. See, that's what I mean. There's just empty runways everywhere. And they use them for whatever. I'm not really sure what they use that one for, but bombing, maybe. Maybe. This kind of looks like they bombed some of them. What do we have here? What is this? Yep. That poor F-101. Those are F-101s. Oh, those poor planes. Yeah, these planes all got strafed. That F-4 Phantom is missing some parts. Yeah, those got strafed. Yep, strafing and bombing practice. See, that's cool. Wait, what do they have? What's chilling out here? Tanks? Oh my goodness. Look at all the patents. Oh my god. Oh! M113s. Look at all the M60s. Ah! No, don't strafe those. You could give me one. Self-propelled artillery right there. That's old self-propelled artillery. That's like Vietnam era. Oh god. Oh god, I'm not happy that we looked at this now. Oh no. Damn. Look at all the freaking M60s. Oh my goodness. That was the US's main battle tank before the Abrams replaced it in the early 80s. Those are M113s. Those are troop transports. Those are all self-propelled artillery. I forget the name of this thing. We still use that thing, but it's a much newer version of it. Those pieces of artillery, which is literally just a cannon sitting on a tracked platform, those are from the Vietnam era. Those are from like the 70s. I forget what those are called too. This is at Eglin. Self-duel. This is, I mean, these are old pictures, so no harm, no foul. This is Eglin Air Force Base in the testing range around Eglin. They do a lot of flight training here, so that runway that we were looking at is just nothing. It's practice runways. Like some of these runways out here, there's just a bunch of abandoned airports all near each other, and some of these runways out here are used for nothing. There's just a bunch of runways. They were used for World War II training originally, and now they just use them for practice. Like, check this one out. This one over here has one runway, and it has a carrier deck painted on it for carrier touch and goes, which is really freaking cool. And then the one we were just looking at looked like the runway that they decided that would be a strafing runway. See, this one has an active, but I have no idea what 36 right here was or is used for. It's definitely not X'd out though. There's all kinds of cool stuff sitting down here. And, oh. There's two F-101s right there. And an F-4 Phantom. And it has an Army Ranger tag. Yeah, I have no idea. I have no idea. Helo skid landings? Oh, Rick, that makes sense, dude. Yeah. Which airfield is where the Doolittle Raiders trained? I think it may have been Eglin, but I could be pulling that one out of my tail, Hellfish. I don't remember. Where was that? So the one we were just looking at was definitely a strafing range. It's this one right here, right? This triangular airfield. And I'm guessing by all the craters in the damn runway right there that they're probably testing and practicing with runway munitions. And then it definitely looks like that. Definitely looks like here there's a Humvee right there, and then if you go down here there's like probably about 20 M113s and probably about I don't know, like 30 M60s. They could be M48s, I'm not sure. I don't know, my tank game is weak. And then lots of self-propelled artillery down here. Bentley Humvee. Cement dummy rounds, probably. Yeah, I mean, they definitely strafed the frick out of this runway, though. See, look at all the... There's a bunch of old plane parts here. There's pieces of F-101s. That's an F-101. That's an F-4 Phantom. Those look like A-1s. I can't even tell. Those look like just fuel tanks and stuff. But see, like, look at all the bullet holes in the damn runway. They definitely used this for target practice. I don't know what that is, but it's in pieces. Yeah, see? They bomb the runway and trees grow in the damn craters. That's wild, dude. Looks like they used a bunch of old Durandals. Yeah, maybe. Metra Durandal. Yeah.
Discovery, go at throttle up.
It's possible. Hey, Wicked, 18-month resub. Thank you. But yeah, Eglin is really cool. There's always cool stuff to see around here. And yeah, they have all the covers out. Because it's covering up those. Nice. Nice. Cool, huh? It's really freaking neat. I mean, dude, look at how big Eglin is. You know, they built this, right? They built a regular triangle airfield, and they were like, you know what? We need more. More! More! You know? I think that's really neat. This is really cool. Oh, looks like they're building another highway. We got cities coming out soon. That's cool. You would like Whiteman? Mm-hmm. You wear large in polo shirts? Yeah. Yeah. Sadly, Eglin lost their A-10 squadron to be host to the F-35. Yeah, see, there's practice. There's all kinds of practice runways out here. Another helicopter skid strip. But yeah, in World War II, you know, they would have you take off, and then without looking at the instruments, they would have you navigate to the dang runways. Or just practice touch and goes and then fly back. But that's why these, like, all these bum airfields are here. That's what they would do. You'd fly, you know, okay, we fly here, take off here, go land over there. That's why there's a bunch of just random freaking runways out in the middle of nowhere. That one hasn't been used in a real long time. But you see all kinds of cool stuff out here. That's a shooting range. That's absolutely a shooting range. Neat. So this was an airfield. Now it has a gun range on it. Cool. Bunch of good stuff. See, there's just random runways. What the frick is this? That's not a runway. It's got a cul-de-sac at the end. That's weird. EJ, you find things that are supposed to be hidden, I swear. Yeah, this isn't anything you can't go and look at. I'm very careful about showing stuff that you shouldn't. These are just abandoned airfields. It's really not a big deal. Cool. Dirt strip. Unprepared surface. Cool. Certain planes can land on those, you know. Like C-130s. C-130s can land on dirt. They can land on anything. Pretty much, Sumo. That's pretty much the rule of thumb. Freaking cool, though, dude. Hurlburt. Yep, C-130s. Do they have anything old at Westover outside of Springfield? Oh, I don't know. I'd have to go look. So Westover's out here. There's Westover and then there's Barnes. They're right next to each other. Westover is not the same as Barnes. Westover has the big boys. Yeah, baby. C-5Ms. Big airplanes. The biggest. That's the biggest plane the U.S. military operates. And yeah, those are C-5s. Those are, well, I'm not sure what those are for. I don't know what those hangars are for. We've actually looked it up, why those hangars are so skinny like that. I forgot the reason. I've done this before. I looked at it a long time ago, now that I'm remembering. Hey, Adam, what's going on? I don't think they have anything out there. Where the frick is Barnes? Barnes is, I thought that was Barnes over there, but I don't, maybe not. Maybe I'm mistaken. Because at Westover, those are C-5s. Out at Barnes, they're F-15s. Different airplanes. Oh, yep, nope, that is Barnes. Yeah, see? Those go a little faster than a C5. I'm just putting it out there. Yeah, big boys. I watch them every day. I was staying in South Hadley. They are big, dude. They are very big. Big freaking planes. You hear them. I don't think there's any like auxiliary airfields like that around here. If anything, you'd probably find an auxiliary at Otis down by me, Cajun. Otis has all kinds of stuff. There are runways that are big enough to land big freaking planes out here. Those runways are super long. So like if the president wants to take a vacation in Martha's Vineyard, that's where the president lands and then flies on a helicopter to the vineyard. Yeah. Otis is a huge freaking range for Massachusetts. It's basically all of this right here in this area right here. It's fun fact, the Space Force has an auxiliary base, and you can see it if you cross the Sagamore Bridge. Check that out. I pointed it out on stream before. It's a huge phased array antenna. And fun fact, it's quite literally pointed directly at the Soviet Union, which is, you know, one of the arrays is basically pointing this direction. Yeah, it points, one of the arrays goes this way and points right at Moscow, which I think is really funny. I mean, it was built during the Cold War. It's pretty obvious why it's there. It's a missile. It was a missile detection radar, but now the Space Force uses it for observations. There's a bunch of these facilities up and down the coast and up into Canada, which is really neat. They use them. The Space Force uses them to look at space debris now, which is really neat. That's cool. Speaking of big boys, C-17's flying the Mach Loop. Oh, the Mach Loop is freaking sick, dude. Oh! Whose footage is this? UK aviation movies. A little humid out there today when this was filmed. I mean, it's the Mach Loop's UK, so yeah, of course it's humid. UK humid, really? Yeah. You see the condensation on the wings, Adam? Look at it. Oh man! Yeah! Send it. Oh, that must be so freaking fun. Oh, that looks like a lot of fun. Oh boy. What is the Mach Loop? It's a training. It's basically it's in the UK and it's used for training, Jim. It's like canyons that you fly through at low altitude. They use it for, well, low altitude flying. Yeah, that's pretty much the end of that story. Yeah, really, really freaking cool. Does it imply the pilots are going Mach 1 through it? No. I don't think you can go fast enough to do something like that. Here, check this out. This is an onboard of the Mach Loop in a Eurofighter.
Restricted descent.
Watch this. Yeah! Now we're talking. This is from Anthony Lovelace. Filmed this footage.
Lead's jet looks good from 30 feet. We're clear for low level and now descending.
Watch this.
Set 250 feet. Throttle set 420 knots. 3G around the corner.
So 420 knots. They're nowhere near. No, not even nowhere near the sound barrier. I mean, it's. Yeah, it's close to it, but yeah, no.
Looking ahead now. Check the valley's clear. Weather's good. Valley is clear.
Oh.
Leads through. Quick check either way. Now we're clear to the left-hand side.
Oh, that's
4G around the
killer,
corner.
dude.
Speed now set 450 knots.
Oh.
Entering the McClellan Loop, North Wales. Hard bank to the left, lining up the overbank to the right. Speed now 420 knots.
That looks like
Back
fun,
down
man.
250 feet.
Two things would happen. I'd probably, either way, I'd enjoy every minute of it. I'd enjoy every minute of it and be totally fine, or I'd enjoy every minute of it and blow chunks all over the freaking cockpit. It'd be one or the other.
Left-hand side. And shortly to enter into the Lake District. Now back down to 250
that's
feet.
so cool, man.
Hard left turn. The lead 6 o'clock is clear. The weather looks good ahead.
Oh, that hurts.
Lining up the valley.
Okay.
And speed now coming up 480 knots.
480, that's booking, man.
Positioning for the overbank. Waiting for the lead. There goes the lead and overbank. Throttles back as we descend back into.
Oh, I'd do this. I'd do this. I could do this every day. Even if it made me sick, I'd be like, yeah, no, let's go.
Lower high corner. Reset. And throttles.
Chris, 85 months, coming in hot.
400.
That looks like fun,
350
man.
checks. 300.
Can't fit in the damn airplane, though. I'm too tall.
Lead 6 o'clock is clear. Quick fuel check.
So, think about this for a second, doing this in a C-17. Like, that's actually pretty crazy. Snibble, they're there nearly every day. I hear them heading east to west towards the loop at around 10:30 to 11. Beautiful sound.
Feels good, but chokeable. Okay, crossing right to left on the lead. Approaching the north of the Lake District this time. Hard right
Alright.
turn now.
Okay.
Valley, 3G.
Okay. Okay.
Speed stable at 420. Height 250 feet. Slight over bank. Throttles back. Allow the nose to come down.
Oh, man.
Maintaining 250 feet.
That hurts if you're not ready for it. I mean, these guys are obviously good to go. Like, if it was me, I'd probably be like, oh, God. You know? Oh, that's cool, man. Sorry, we went on a plane tangent today, but it is Wednesday, so it's okay. Also, I flipped back over to ADSB. Some F-16s flying around. Top Aces Corporation. Oh, looks like we got some Op Force stuff going out of Eglin. That's cool. See? Not military. Top Aces. So, that's actually super cool. That's Op Force stuff. Opposing force, or an aggressor squadron. Yeah, they're operated by companies, and the military contracts them out to be enemy planes. That's cool, man. That's the kind of stuff that Jared Isaacman used to do. He doesn't do it anymore, though. Yeah, flying Op 4. So, you go train on, like, a MiG, or, you know, an F-16, or not, I mean, F-16s work good enough, right? You train on some plane that's kind of similar to the enemy's capability, and you go and fly their tactics against USAF pilots, or Navy pilots, which is still cool. What's he been up to? He's training for Polaris Dawn, Tars. Polaris Dawn should be going by the end of the year. That's an EVA. That's a SpaceX EVA. So Jared Isaacman, Rook is going to test out SpaceX's EVA suit. Yeah. Super freaking cool. Yeah, that's Polaris Dawn. That should be happening in a couple of months, which is, once again, Dragon is going to fly up with Rook in it and Stuckey. And I think that's the crew. I think there are two more. I'm pretty sure there are two more. And yeah, there's Anna Menon, and I forget the last woman's name. Either way, they're going to go up there and they're going to depress a Dragon capsule on orbit, and they're going to EVA, like Gemini style, which is freaking cool, dude. I believe F-117s have been doing aggressor rolls recently. Yeah, Snib. Either that or they're doing some flight test evaluation on them. It's one or the other, dude. My guess is flight test evaluation, but they could be doing that too. I'm not saying you're wrong. But my mind. Oh, that C5. The other C5 that flew out of Travis is. Where's he heading? Flying over Bakersfield at what altitude? 25,000. Oh. Yeah, I have a feeling I know where that guy's going. See? Oh, cool. Cobra. Ah, I wonder what that guy's. Yep, see? Another OP4. T-38. There's so much stuff. Like, I can't believe that. I can't believe there's so much stuff. Oh, there's El Mirage. Cool. El Mirage is where they do land speed records and stuff in El Mirage. That's really cool. Stream from Red Flag already, will ya? Flight 62 is coming up. They are going to do more helicopter on Mars. That's cool. Yeah, man. I could sit here and look at this stuff with you guys all day. I think it's so freaking cool. There's so much, like, it just blows my mind that there's so much stuff going on. Look at all of it. All right. That's all the planes flying over the U.S. that have their transponders on, and that's pretty much every single civilian plane. But there might be some military planes that don't have their transponders on. That's just the military, which is okay. Spooky, Viper, Jaws. Yeah, that's cool. Aberdeen. Interesting. I wonder what those guys are up to. Yep, more training. Trainer planes. Look at all, dude, just look at how many T-38s are just tooling around all over the place. There's another Chinook. Cool. What's that guy? Nah, it's just, oh, it's a Super King. Super King Air. That's a cool airplane. What's this dude? Interesting. Oh, an H-60 just went out of Otis. Enjoy the new golden age of flight. It won't last forever, right? This is freaking awesome, dude. There's so much good stuff. There's another UH-60 that... Oh, yep, that guy's doing touch and goes. It's training flight. Where did he fly out of, though? Let me take a look. Oh. That's the one that we saw come out of Windsor Locks a second ago. And he's doing touch and goes at Westover. Cool. Yes, touch and goes with a helicopter. That's absolutely a thing. The thought of what's up there without the transponder on gives me the willies. Yeah, right. Pretty cool, huh? All right. Well, that was a cool space airplane news Wednesday thing. That was pretty cool. Wonder if I'll be live when we look at rocket launches like we do planes. Latte, we're almost there. SpaceX is kind of making that happen, dude. I mean, here, look at next space flight. Look at how many. Just look. Out of 9 launches here, 5 of them are Falcon 9. Falcon 9 is flying sub 4 days, so 1 every 4 days. SpaceX has launched 70 Falcon 9s this year. 70. 70. What in the frick, man? Any buffs airborne? I didn't see any Tigris. It's one of my favorite airplanes, dude. Like, look at all the Falcon 9s that are teed up, man. It's ridiculous. There's another Falcon Heavy in November. That'll probably launch sometime in mid-December. But still, it's still crazy. Anyway. All right, fellas. I didn't tee up a game today, to be honest with you, because driving into the city is super freaking tiring, and I'm actually kind of spent right now. But we also have to get up for OSIRIS-Rex in the morning. Or not OSIRIS-Rex, Psyche, excuse me, if it decides to go. Now, it doesn't look like it's going to go, but I'm not going to not be here either for that. I don't think B-52s are ugly, to be honest with you. I wonder how SpaceX will transition from a person-per-system control center to something more airline-esque. I don't know. Hellfish, part of the reason why I think Starbase is taking so long to get approved for, like, routine launches is because that's the right question to ask. That's part of the reason why it's taking so long with Starship. I think that's honestly has a lot to do with it. What does a commercial spaceport look like? They did, Gujar. Yeah. Like I said, guys, I'm kind of spent. I know I haven't been streaming much this week. I'm trying to reset so we can get on a routine schedule. It's just, yeah. We'll get more on a routine schedule next week. I don't like not streaming this much, but I'm also really tired. Don't really feel good. I didn't get much sleep last night. Well, stop being tired, yeah. So, fellas, I'm probably, we covered OSIRIS-Rex and everything. I'm probably going to call it here, but I'll be back tomorrow. I mean, and tomorrow's going to be a really long stream because I need to get up early. So, hey, Linus, you're just catching me kind of at the end here. Was it school? Did you do 5 hours of space news today? There was a lot to talk about, Jax, because of the OSIRIS-Rex. OSIRIS-Rex findings were released today. NASA found water on the asteroid. I'll say that again for reiteration. NASA found water on Bennu. That's kind of a big deal. Nice, podcast worthy. So we've been talking about that, and then we kind of went on a plane tangent, but that's fine. Plane tangents are good too. Any X-57 news? Nah, not much. Nah, I haven't heard much about the X-57. Anyway, so, fellas, I'm going to take the rest of the night off to kind of reset, and I'll see you guys here tomorrow at noontime. Well, actually, not at noontime. So, the Psyche mission's set to go off at 10:16, so I'll probably be here around 9 o'clock, so I'll see you all in the morning. And what I'll do tomorrow is we'll stream the entire day. So yeah, we got a lot of stuff tomorrow. I want to play Kerbal. I want to get our SCRV Stoke Space Project Hemi thingamajigger going. Yeah, I played Hearts of Iron later than I really wanted to, Erudite, and I didn't get a lot of sleep because I was up at 7 o'clock. And one of the things about work is that you can't just go home and go right to sleep. Like, streaming is just like any other job. You gotta, I got off work at like 11, made myself some food, cleaned up, cleaned everything up, took a shower, and then kind of basically went right to bed and sat there for an hour waiting to go to sleep. You can't just stop streaming and go right to sleep unless you've been doing it for like a long time, like 13 or 14 hours, right? So, yeah. Does anyone remember that train game EJ played a while back? Sure, Silver. It's called Derail Valley. Yeah, Derail Valley's awesome. They actually added more stuff to that. We could, maybe sometime next week we'll go and dive back into it. So, I kind of want to just keep doing, I want to do more Kerbal stuff, but I want to get back to doing Kerbal stuff and then just kind of round robin of other games for after hours and stuff, like City, Summer Car, Satisfactory, Derail, stuff like that. Anyway, so I'll talk to you guys tomorrow. Thank you very much for watching. I'm going to take the rest of the night off and reset. And I will see you bright and early for the Psyche launch tomorrow. It's probably going to scrub, so we'll probably end up just playing Kerbal all day. Not a bad problem to have. Nope, it was Railroads Online. Everest, did you just tell me what game I played recently that had to do with trains? Okay. You played Railroads Online. Yeah. Chat-splaining. Kurlani, is this what mansplaining feels like? If so, yeah, no, that's... Yeah. Yeah. Yeah, this is uncool. Yeah, I don't like this. Yeah. I don't like this at all. Anyway, thanks for watching, everybody. I'll see you guys tomorrow, 9 o'clock. Psyche mission, man. We got the asteroid sample back from OSIRIS-Rex, and now we're sending another mother trucker up there. So I'll see you guys tomorrow. Thank you very much for watching. Have a good night.